Hack the planet with the Ranger check. Let's go check on Ranger. How is he doing? We're going to need to have that up anyways. So give me a second here. Let me pull up my Ranger cam. How's he doing down there? Ranger looks like he's doing all right. He is, he's getting old. He's having a hard time standing up now. So that's Ranger for you. Good dog, but getting old. How's it going, Hack the Planet? I'm drinking a energy drink with ice. We are, so I have been meaning to put together, I've put this together, the ProLUG PCA study guide, and we went over it a couple times, but today I went through and I kind of cleaned up all the last pieces, so I'm going to go through it one more time. I'm going to schedule my test for middle of next month, I guess. Gives me a little bit of time to study and work on it, but if anybody wants to look at the body of knowledge around getting a Prometheus certified associate cert, you know, not everybody's going to want it, not everybody's going to need it. For me, it doesn't, I wouldn't say it advances my career any. It's more just they had it on sale, so I bought it kind of as a cheaper one than others. But yeah, I think Prometheus is a great tool. I'm going to give you a bunch of tricks and tips in here to get better at it, because there's a bunch of tools that are out there to kind of help you. For anybody that's trying to get better at it and work on it, you guys can do that. Also, I should probably just go ahead and, while I'm here, open up my Prometheus in my lab. What is my Prometheus in my lab here? I gotta find that. Hold on, because I do not remember right off where he is. Let's go this way. Let's go to, where's Prometheus in the home lab here? 193. So let's go to 193. Nope, that's not going to do it. 192.168.11.193. There we go. So here's my Prometheus in case I need to do any data queries or any of that kind of stuff. Yeah, there's some really good tools. In fact, Hack the Planet, just because you're here and because you are using it in your home lab, can I show you one of the best tools out there real quick? This cheat sheet right here. I'll link it here in a second. This cheat sheet is awesome because when you're ready to do whatever thing they're showing you, you just click the open in prom lens and it drops you in their instance and it gets you exactly what that thing is. But then once you understand it and have seen it, then you can go throw it down in your own. So hold on, let me link this up for you there, and then also on the YouTube side for anybody that wants that. This is like one of my favorite things when we get into this part of it, just because like you're like, okay, how does a series work? Okay, I can go open it up in their tool, but okay, I understand how a series works, and I'm doing all node CPU seconds, good, and then I see these labels, so now I can start to carve down by the labels, right? Each of these labels, but also I can go do that in my home lab, right? Because my home lab should have that same stuff because I've got Node Exporter running, and then I start going, oh well, I can see that same stuff in my home lab, and then I can go, well, I only want to know about instance of maybe one of these guys, right? Maybe I just want this one node and I only want him in when his mode is equal to idle, right? Let's put that like that, right? Mode equals idle, and then maybe I'll execute this query and it'll say, okay, it's only that one, and then I can say, well, I want that for the last like 30 minutes maybe, right? And then now I can see the series of it, and I can start to learn how this works. So that little PromQL cheat sheet is so good for understanding the PromQL portion of this. Isn't it the same as Grafana? No, Timidus. So what Prometheus is doing is Prometheus is acting as a it's not a key value store really. It's a metrics database, and the metrics is still based in key values. So this thing is at this time, whatever value, that's what you're seeing here, right? But then you can go back and query it. So no, Grafana is viewing this. Well, in this case, Grafana is just viewing Ranger. But if we go to like ProLUG, and then we just look at like our stuff here, this is a representation of that. Grafana is more like I could give this dashboard to a bunch of you guys as generic users, and I could give you a generic login, and you could just look at this dashboard to your heart's content. but you'd never have any power. Prometheus is much more of like your interface to the actual database, because Prometheus is, at the end of the day, a time series focused database, but it's based on key values, right? So anyways, no, to answer your question, they're slightly different as the way that I look at it. Let me show you so in my home lab, I'll pull this up just for some people who haven't been here for this before. Let me show you guys what it kind of looks like in my lab. Look for monitoring. This is kind of how my monitoring works in my home lab here, right? Well, actually, it's exactly how my monitoring works. It's not kind of. But all of my monitoring goes through Grafana at the end, right? That's how I visualize it and show it to you guys. But we've got all these different things feeding data over to... So this is my ingress tier. This is my aggregation and storage tier, if you will. And then this is my presentation tier in the monitoring type stack. So I use Node Exporter. Prometheus comes along and pulls it every 10 seconds, gets all the data, and I can see what's going on in my environment. So that's kind of how it works in my home lab. Some of you guys have been around. I have projects that have you guys build all of these pieces. You can go do those up on Killer Coda. They're all free, all that good stuff. But we got all that stuff. I think we're good. We did our Ranger check. Ranger's spinning in circles because who knows why. I showed you guys the PromQL cheat sheet because I think that that's really good. But let's start back up here. You know, we'll play it like, hey, it's starting right now. This is the Prometheus PCA study guide for the certification by the Linux Foundation by, well, me. And apparently it says 2024. I don't remember putting that on there. But this is for the Professional Linux Users Group, right? So what is the PCA? It is from, again, the Linux Foundation. Its cost is about $250, but like when I bought it, it was 40% off, so I think it was $175 or something. But the number of questions is 60. You've got 90 minutes to take them. The format's online, and you need to get 45 correct, which is greater than 75%. And then you do get one free retake with this test. I haven't taken this yet to see how it is, but I've done some of the Udemy stuff on it and read about it. Freedom DAO, it's $250, but you can find, they're always doing sales. Like every couple of months, they're doing a sale. So I got mine for $175. And again, I kind of put this down just like for a stretch. There's not really like directly related to my career. This doesn't affect me that much, but it is a good one, I think, to have to understand, because a lot of systems that I'm building out, in fact, I'm working on a system earlier today. I was building a system out in between last time we talked when I was online and then now. I was building out a system that has Prometheus as the monitoring component, Prometheus to Grafana. So yeah, so this is good. It's valuable, right? Get your hands on this a little bit. So here's what the test is about. Everything is about 20%. Now you might say, well, these are a little lower and that's a little higher. Sure. But there's 5 areas. The one you do want to focus and really understand is the PromQL. But I feel like this one's the easiest to practice, because again, we have this right here, which is this nice little tool that somebody built for us, PromQL, and we can go see how a lot of these components work. So I'm going to link this one more time for you guys, just in case anybody needs it. PromQL is the query system for the Prometheus app. Yep. So there's the link. You guys can drop right into this. You can go and you can look and say sum all the nodes in the file system, and then you can pull it up and you can actually look at what that looks like here. And then you can even see it as a graph if you want to, if the graph makes any sense, right? And then explain. That's even better. Look at all that. So, strictly speaking, what we normally do is I shouldn't have closed it, but one of the things we do is we use Prometheus to query the data, and then we turn those things that we're looking at into Grafana dashboards and individual tables and all that kind of stuff over there, right? So these are the things we need to understand. We need to know how PromQL works. That's huge. But then this other stuff like observability, how do we push and pull? Where do we get tracing? What's a trace versus a span? And since the last time I did this, I went through and I had a bunch of notes of things that I needed to update. So I've updated all of them. So this should be about as ready as we can be. System architecture. When we get to the system architecture part, I'm going to give you guys 3 different ways to build out Prometheus. We had it mentioned earlier that Hack the Planet just built it out in his lab. That's one way. There's two other ways I'm going to show you to go build out Prometheus. And when you do that, you'll better understand the system architecture and the scraping type stuff. But that's going to be for you to kind of go, you can configure that and do those kind of things, right? But we'll talk about that, and I'll give you all the tools to go out there. They're all free. There's free tools out there. Even if you don't, you say, hey, Scott, I don't have a whole lab like I have sitting behind me. There's all kinds of other things that are out there for you guys to work on. So instrumentation and exporters, you need to understand how data is getting out of systems. And then configuring the dashboards, again, aren't as important, but they're all about 20% across the board. They borrow a little bit from these to make that one higher, but all about 20%. So here's the things that I think you need for your hands-on environment. If you want to do this hands-on, there's two ways to do it inside of Killer Coda. Killer Coda is a 100% free site that exists out there in the world. One is I show you how to build it onto a server. So Prometheus will build onto a server with this lab. You will actually go, oh, that went over there. Pull this up here. And this lab will walk you through how to do that. So I'll link you guys that lab. Also, the unfinished version of this is up on our Discord for anybody that needs it. So if anybody needs our these, you're like, oh, I can't look at this right now, but I can go look at it later. You can always, let's go back up one here. You can always go grab this off of our Discord. If you say, well, where the hell is it at on your Discord? You go to the Discord. You go down to our, should be under presentations. And where's PCA? I don't see it there, so maybe I have lied to you. I'll put it up there. I'll put it up there right now. Hold on. Let me make sure it's. Let me make sure that it is. Hold on. Let me make sure it's saved. Look, I don't like lying to you guys. So I'll go grab the actual Prometheus certified right here. Put this over here. Hold on, guys. Because sometimes I say things and then people come back to me later and they're like, aha, you're a liar. And I'm like, I don't want to be a liar. So here's our, I think this is as prepped up, as ready to go as it can be. All right, so there's all your links and everything, right? There's all your links and stuff. It's right there under presentations for anybody that wants it. All right, let's get back into it. So again, if you're here, this is your building it out as a server. If you just want to do the quick Docker build and just get to a running system, this one will create a dashboard with Grafana, but it'll do the whole build out in Killer Coda for you, and then you have all the pieces that you can go work on. So these are two free places to go build Prometheus and work with it, right? So if you see this stuff and you're like, oh, that seems like that would be a really good cert to maybe put on my resume, or hey, I've been meaning to get more into this, whatever this tool is and understand how monitoring works, this is a big part of it. If you want hands-on practice, one of these guys, there was a guy who put together, is Stefan Prodan. Yeah, he put together this doc prom. And if you go into this one, I remember looking at this, it's got a pretty straightforward, one of our guys had built it. You just download, you just git clone it, cd to doc prom, set up whatever you want, and then you do a Docker compose up. Now, in that instance, if you do that, there's a few things you probably want to look at, in that you need Docker Engine and Docker Compose on your system. Instead of Docker Engine, you might be able to get away with like Containerd, which most people use. There's probably some stuff that you could play around in here, but then he shows you how to set some stuff up. And this one, I would call this one a little more like engaged, but you could run this on a laptop that had some decent power. This type of thing here. And I'll let you guys play with that if you want. But again, if you look at that and you go, that's too much work, that's too complex. These are hour-long scenarios that are free in Killer Coda. That you could just go hammer out, and then when you're done, put them away. You'd have to restart it, but it would be good because you would be understanding the build process and all that stuff. So, the Mad Monk over on YouTube, thanks for coming by. We are going through PCA. This is the Prometheus Certified Associate. I'm going through my whole study guide. I'm talking through it to help myself remember some of the stuff, and I'm doing my own study as well. And then this is the one that I linked a few times earlier. It's from Prom Labs. These guys have some really good stuff out there for free, they've got the PromQL cheat sheet. So this little cheat sheet here, you just want to understand what it means to select from a series. They will show you how to do it. You want to know all the node CPU seconds for the last 5 minutes. You hit open in Prometheus, and it opens up in Prometheus, and it aggregates all of these things up for you. In this case, it's from Node Exporter on 9100 on this instance. So whatever is considered Node Exporter to them, that's probably a resolved name. Hey, how's it going, Quartz One? I am, I'm doing good. I don't know where the wife is. She was cutting some of her friend's hair, and she's out for the day. So I streamed a little bit earlier before my college stuff. Then I did my college stuff. None of my students even showed up, so it was like a strange study group where I just kind of sat there by myself and nobody showed up. And then now I'm back on here going through Prometheus and showing you guys that there's all these tools for you to use to practice. If you want to get into this and want to get good at it, not even for the cert, even if you just want to get good at it, there's all these free tools out here. Everything here is free. So you guys should do that. You guys should get in there and play with that. Oh, thanks for that, Quartz One. And if anybody got a gifted sub, 1, you don't have to watch ads anymore. 2, make sure you let Quartz One know that you appreciate him. I'll raise my Burger King cup filled with Blue Monster. Right, Blue Monster, because it has no calories, but it's actually really good. All right, so now we're going to break down each of these pieces. We're going to go in order. We're going to go through them. I'm going to talk through stuff. I'm going to show you guys some more pieces of it. Again, all this, if you have a hard time following along with me, because I know I jump around a lot, there is, I just put this up on the Discord for you guys right there, as ready as it can be, as ready to go as it can be. So there's the Prometheus Certified Associate Prep. Also, can I mention one other thing? I meant to mention this earlier. We have a bunch of events coming up that are free. All of our events are free in the organization. The Professional Linux Users Group is just a bunch of us guys that get together and hang out or whatever. Arth Vader, how's it going? I'm doing good. I'm always doing good. I'm very overworked though, and next week I'm going to be out in Austin for a whole week. So it's like I'm going to be very busy. I'm going to be trying to run my new college classes because I'm starting new college classes. One of them on Thursday. I'm supposed to be physically in the building, but I'm going to have to cancel that and move it to like the next Monday. But for you guys, free stuff. Free stuff is the best stuff. Well, not always, but in this case, free stuff is good when it's like driving to a end. Some of you guys want to be software engineers. The Code Cove, this is Salty. And Salty was messaging me earlier, so I don't know if he popped on stream or anything, but he's been running this Blitzcrank and building out different projects for you guys and showing you guys how to operate on a software engineering team, which is, I mean, nobody's teaching that. Like, people teach you how to, like, watch them do Vim or NeoVim or whatever, and people teach you how to code, and people do all this other stuff, but not many people are teaching you how to, like, do proper branching and get commits and stuff within a team. And that's kind of what he's been doing for people. So I think that's invaluable. And if more people keep showing up to this, we're trying to get Salty back streaming again, because he used to stream a lot, and I'd like to get him back streaming. We have a really good talk coming up on engineering and pre-sales engineering. This is from a guy who works at Red Hat. He's been at Red Hat for, 7 years, 8 years, somewhere in there, he'll tell you. But he'll talk about engineering and pre-sales engineering. And then we've got a 16-week Linux Systems Administration course coming up for anybody that wants to do that. Again, all that stuff's free. You just go in there and play with it. All right, let's go. So observability concepts, 18% of our overall. We got to understand metrics. We got to know why we would use certain metrics in certain places. Then we need to understand logs and events and how we can turn logging on within our Prometheus system. Then we want to understand tracing and spans, push versus pull methodology. We very rarely ever use push. We almost always use pull. And then service discovery. How do we tell Prometheus where the services are that it's supposed to scrape? And then the basics of service level objectives, service level agreements, and service level indicators. How do those all relate to each other? All right. So metrics, there's counters, gauges, histograms, and summaries. Counters are cumulative, and they represent what they call a monotonically increasing counter. So counters monotonically just means that it moves only in one direction over time. Now, monotonically can still kind of gradually go down, but as a general function, it's going up, right? Or it's going down. Monotonically can also mean it's going down. So counters basically are moving in one direction is the point of what they're saying there. Now gauges, however, gauges are going up and down. Your gauges on your car, like your speed goes from 0 to 50 miles per hour, down to 0 up to 50, or however fast you're driving. That's a gauge, right? It's constantly moving. Histograms are samples and observations of things in buckets. So what that means is if I have a bunch of student test scores that I'm looking at, right, and they're sitting like this, and those student test scores can be between 0 and 100, right? That would kind of look like a gauge, but I say no, hold on. I want a histogram of that. And I'm going to show you guys these in a second. You're not just going to have to look at my hands. But what a histogram is I put those into buckets. I say, well, how many students were between 0 and 10? Well, there were 0 of them. Well, maybe there's one student. He didn't turn it in. So there's one instance of 0 to 10. And then there's 0 instances of 10 to 20 and 20 to 30. I'm being general here. I'm not like saying 20 to 29. I'm not doing that. But as a general, our buckets are, then we can look at the distribution of the events through a histogram to see patterns. Is this thing a what we call a standard distribution data set? Is a bimodal distribution set? We'll look at all that stuff, right? I was thinking, is it binomial, but no, it's bimodal. Somebody help me out. Who's my math guys? I know I have some math guys here. They'll correct me. That's the thing. You can talk about math or judo online, and people will come out of the woodworks to correct you, right? Anyways, histograms, that's what they are. And then summaries are similar, but they're just a summary of times and durations and response sizes, all right? Monatomic functions, again, that's a mathematical term that means generally something's going up or generally it's going down, and counters are really useful for that. Now, if it fluctuates a lot, that's more of a gauge. If we want to annotate the buckets that it fell into, that's where histograms come in. And I'll show you guys that here in a second. Jobs and instances. Jobs are collections of instances. Instances are any endpoint that you can scrape. Okay. We aggregate instances up into jobs by putting labels on them, right? And then labels are things that we can then look at spans and traces of when we get to that part. So there's all these terms, right? And look, guys, anytime you take any certification test, you just need to know their terms. That's like a base functionality. That'll get you like 20% of the test questions, knowing the way that they name things. Then the rest of it is obviously, knowing these pieces here or whatever. But all right, so let's go talk about logs. You can turn on query log and write all queries to server in a file. So everything that happens in our system can be added. In my home lab here, and for some of you that want to maybe mess with this a little bit, we set this up. I thought I had let's go SSH to Prometheus. I thought I had this set up. I thought I had a server for it, but etc ls cd Prometheus. And in here, if we look at our prometheus.yaml, you'll see that the one time that we were doing this before, I set up my query log, var log prometheus query.log, right? So I could take that right here. Watch this. I can go tail-f on that file, so that'll follow it in this window. Not everybody here is a Linux engineer, but that's what we do, right? We tail-f and we follow it. We do a couple of enters just so that we have our own space, and then we come back over here and we go, well, here's my Prometheus. Let's do this query again. I'm going to execute that query, and look, immediately from my laptop in my local system here, I did a query with these parameters that I wanted to see node CPU seconds total for that instance with that mode idle for the last 30 minutes. And that is a record of all API queries logged in my system. If you don't turn that on, if you don't turn on the query log file, there's no record of all the logs and all the things that have happened to your Prometheus system. In fact, before we did that, one, I wouldn't have had that up. But two, that query that I just did would not have been tracked here. Now, let's say none of you here are security engineers and have never done anything with security. Let me just ask you, do you think security probably wants to keep track of every query that goes against a database that you have out there that's running, maybe in this case open in your environment? Yeah, you better believe literally everything should be tracked in the system. the cost of this right here, like if I were to try to factor in what the cost of that little log line right there is, what is that? Maybe, I mean, I wouldn't even say that's, let's call that a kilobyte. It's not, but it's way less. But let's say that's a kilobyte. And I was going to factor in all of the times that there were requests and all of those kilobytes added up over the whole year. I would probably just barely be out of the dollars for the year. Now, to be able to go back and see everybody who's ever queried anything of your Prometheus monitoring for your whole organization, and to know that you could go back and trace everything that's happened for the last year for like dollars, that's I assure, and I'm not even talking tens of dollars. I'm talking like single dollar bills. That's pretty cheap to an organization. Like this isn't even going to get. I think last time I checked, 1 terabyte in an organization is like 17 cents a year or something to run for most organizations. And I'd be willing to bet on big organizations that's even cheaper. But it's something like, yeah, it's like 17 cents a year for you to have a terabyte of data just stored in most organizations. That's including the encryption of it and the backup and all that stuff. It's like 17 cents a year. It's like nothing. So anyways, my point is that wouldn't even be, registered. All right, enough about that. The log format is JSON. Do we see that? Let's go look. Whoops. Do we see that this is JSON format? Yep, look, I got an open curly bracket and a closed curly bracket, and I can grab that right there, and I can then go to temp, and then just VI sum file. All right, it doesn't matter. Just drop that in there, escape :WQ, cat sum file, and then run it through JQ if I have it. Oh. Let's install JQ. That's our JSON query, right? And we'll look. Let's look at our, yeah, whatever. Sure. I think that's because I put needs restart on this box, but we'll just pretend that's not happening right there. We'll give it a second. All right. That was an adventure for one simple little thing. Yeah, look at that. So when you run it through, when you cat out that JSON entry, and then you look at it through JQ, that's real pretty, isn't it? We see all of our key value pairs. We see all of our, so this is HTTP request, and then this is a breakdown of it from here to here. Each of the components is a key and a value, a key and a value, a key and a value. Yeah, look, that's all the little tasty data that I might want. And very useful, that can be fed very easily over into Loki or some other tool. In fact, I think in this box, when we did this before, we went to opt promtail. I'm pretty sure that then in our promtail local config, I'm pretty sure, yeah, we took this log and we sent that over to Loki. So now, and so you might say, well, why do you show us all that? Well, because now in my home lab, if I come back to this one and I change this over to my logs and apps, and then we're going to look for, what's the job? Prometheus? Let's go look for the job here. We should be able to look at Prometheus. We'll take off the failed, and we should be able to see. Here's that last one right here. 1427. Yep. That's that breakdown of that query that I just did on the system. So, not to overcomplicate the issue, I just want to show you guys that when you do logging, you can do all kinds of other things. If you don't do logging, then you can do this for yourself. No, I'm just kidding. All right. Blur that out. Cut that out, guys. We'll edit that out and post. You guys know I don't do any post stuff, right? I don't really do any of that. But my point is, you have all this like functionality, and this log doesn't have to stay on this machine. This log can get slurped up into what we call our SOAR, which is our, well, SIEM first, which is our security information and event monitoring, or our SOAR, which is our security orchestration and remediation, right? So that SOAR tool can look and they can see a bunch of weird queries coming into our query log, and then we can start to deal with it and maybe cut somebody out of the network and do, there's all kinds of things you can do. All right. So tracing and spans. This comes directly from the Grafana Labs page, and I wanted to show you guys that trace represents the whole journey of a request as it comes into your system. So, there's some request that comes in and it starts moving between different components and systems, and there's some context applied to it. Context, any of this stuff just means a label, right? So context is a label, like a job. In that last line back here, we saw that this had its own label for going up into Loki. Stuff will come in and it will have a label, and then it'll move through. And the better you label things, and the better you label pieces of your job and components to be scraped, as we get to the scrape component part, this will be easier to do. Now, this right here, what we call a trace, there's a lot of money there's a lot of effing money in this. And when I say that, I mean like the companies that are really good at this are like New Relic, Datadog, and I've seen New Relic. I saw New Relic do this one time. I was super impressed. We had a web server front end, we had a database back end, and then we had like an application in there talking to the database. So it was web, app, database. And we put New Relic on each of them, and then we took the New Relic app and we we set it up with there's a application key, like an API key that you put into each one, and they all talk to the same bucket. And then I watched this in real time happen. We started doing web requests. Our app guys started doing web requests on the front. They would hit the app, and then they would go hit the database. And in real time, New Relic had this, but it was turned to the side so it looked more like this. And they were showing the person's web requests come in, that process ID, all the way through to where that made the call to the API to do whatever it was going to do, back to the database. And it showed across all the systems how all the data were flowing. And that was super impressive. There's a lot of money in that. Companies pay a whole lot of money to track this. You can do it with Prometheus, but it takes a little more context you have to apply, and you have to understand how your data kind of are flowing, and that makes it more difficult. Because for me, I'm down in the basement just keeping the servers running, and maybe I start building out a tool. This is how a lot of my career's been. I'll build tools to monitor stuff, but I won't understand how their data's working on top. So I'll be tracking my Linux servers really well, and I'll know like the load of my systems, but unless I'm being integrated or somebody from that side is pushing down to work with me, it's very hard for me to understand how their data are flowing around, if that makes sense. So this is one of these things where, the person who wants to track something from start to finish, they have to like look at the system holistically. Whereas, like I tell you guys, I'm down in like the engine of the ship, keeping all these systems moving. I care about how much disk space I have, how much network utilization I have, how much memory I have, and how much CPU I have. Right? Those are the big four that I basically have built my career on. Right? That's not to say that these other things aren't important. This is where the money's made. Right? How the web app and how the end user is seeing things is actually where the money's made in an organization. That's why I tell people, like, a lot of times in my career, I've been like the stepchild. The app teams will come and yell at us, and it'll be like, we don't think that's a good idea. And then the management will be like, do it, because they're the ones making the money. And I'm like, all right. It's a little different when you work at a company like when I worked at Lockheed and I was the engineer and I was the person who made the company money. Then I was the one who got to be the tyrant. No, I'm just kidding. All right, spans work like this. So trace is this here, and a span is the time you want to look at it. So you may do, a trace of A over some amount of time, and this may be moving between systems, but typically all of these are still governed by your context, whatever label you put on them. All right. If you want to go look at that a little more, go look at Grafana Labs. They've got some good information there about that. All right. Push versus pull. Push refers to the endpoint pushing data into a Prometheus instance. That's never the preferred method. This should be used like less than 5% of the time. If you must push, there's a Prometheus push gateway. This is not an aggregator or distributed counter. It is a metrics cache. So don't treat your Prometheus like a place to just aggregate a bunch of data or, distributed counter. Like, use it as a metrics cache. It should be caching things that are being sent to it, right? Pull is more of what they want you to do. And the reason is because there's certain things that as you pull, you get a whole bunch of advantages. If you constantly pull from a device and it's ever not there, you can tell that the device is down. Well, the device is not responding. I knocked on its door every 10 seconds and it didn't respond. That means it's down. Well, if you contrast that with this, well, if we're just pushing data whenever we want to, when's the timeout of that? By the way, I used to watch this all the time with Nagios or Nagios, as people like to say. With Nagios, all the time, it was a problem of, well, if data are being pushed, when do I finally check that and call that not just stale data, but the system is down, right? When can I do that? So that was always a problem. Push is not great for that. Pull is better. You can go target and expect health with web, like over HTTP. Instances are easy to add and remove, but there's a warning here that comes from push. Pushed metrics are never removed unless you go and manually remove them. If you one time for fun just push something into your database, you just go do like a write, that will stay in that database forever until you go and manually go to the database and do a purge command on it, on that specific piece of data. It won't leave any other way. Whereas these pull metrics, over time, they get pruned out, and there's a pruning process that we're going to configure here in a little bit. All right. So service discovery. How do we set up service discovery, right? There's file-based, where we can use node exporter to expose things. You can change the port number if you... 9100 is also Copilot, so Red Hat, right? So you might change it. It's useful for the up metric, and then there's... If you're using HTTP-based, the response code must be a 200. It can't be any other type of response. The content body type must be application JSON, and the body must be invalid JSON of what you get back. So how do you set up this service discovery? How do you tell Prometheus what it's going to go scrape on the system, right? This is right here. So let's go back to where we were. Let's see, Prometheus. We just cat it. Here's my scrape configs that do all my service discovery. So I've got a job named Prometheus, and that's a static config against this one target right here, localhost 9090. My system grabs its own Prometheus configs. That's a big surprise, right? Then down here, there's a Prometheus node, which is my system looking for its own localhost 9100, and this right here will only work if 9100 is exposed, in this case by like node exporter. But let's go make sure. ss-ntulp grep-i for 9100, and there is node exporter exporting port 9100 for me, and I can also do that. Like, there's another way to do it. lsof-i:9100. This will show any open files related to the port 9100 on the system, and there's all the node exporter doing whatever it's doing on our system. Cbear495 said, hello, Linux. Question, would you suggest Linux certs to go into Linux sysadmin work? What do you suggest I would need to break into Linux systems industry? So Cbear, I don't think you need a Linux cert to get into the industry. I don't have a single Linux cert. I have all kinds of other certs, but I've never gotten a Linux certification, right? That being said, the things that I would do to start would be get hands-on, get a lot of experience, right? The ways that I would do that, I would posit that we have a group that you can go to, which is the Professional Linux Users Group. Everything up here is free. But then I have a little section here called Beginner Start Here. And what I would start with here, if it were me starting all over. By the way, guys, you might say, well, Scott, you've got a whole bunch of college and you got a background in all this and you teach, sure. But I only had one Linux class ever, guys. I learned all my Linux in the wild. All my Linux was just by doing it. By being the guy who had to fix a thing, right? Yeah, do all the Linux. That's the thing. So, like, there's this YouTube. Obviously, I want you to watch the YouTube and hopefully like that. And these go in order. There's a little, I think, a list for it. If you say, well, Scott, I have some background, but I need to bolster my resume a little bit. I'm not going to spend 4 years in college. Fine. I want to just get some certs out there. Here's 6 certs that are free right here that you can go work on. Just do Discord. Discord will get you there. And then inside of the Discord, go to the Beginner Start Here. Right there. And here's a bunch of them right there that are free to take and free to study for. So, you just start working through them. I think the ones that I would start with if I were new, I would start with this API one because literally, I don't care if you're a Linux engineer working down in a basement. I don't care if you're a software engineer. I don't care if you're a SRE or a DevOps or a secure, like just right in the middle, you're doing security shit. You will touch APIs in your career. APIs are the best, most stable, most de facto standard of the industry for what we do. And you say, really? And I say, yeah. I could go to the Splunk document. I haven't used Splunk for this ever, but I 100% guarantee you there's an API for Splunk. Never even hit it once, but I know there is one, and I know it's well documented. Literally every Red Hat tool, everything has an API to it, right? I did get accepted to the network administrator job at my local Unix college. Currently working on taking Linux 1 right now. Yeah, Seabear, that's all excellent. We have some guys who took some of their Linux certs. I am a big fan of any body of knowledge BOK, right? BOK. That's what we call a body of knowledge. That gives you structure around a thing you're trying to learn. So you can go study for an LPIC or a Linux 1 or whatever these certs are without even taking the cert, and I would still tell you that's good. It might not be as good on paper, but it's good for you, right? Oh, there's Rob. Hey, Rob, how's it going? I saw you walking around downtown somewhere earlier, and you only had like 9 or 10 people at the time, but it looks like you've expanded by hanging out. What's going on, Rob? What were you guys doing? I mean, I saw you walking around earlier, but for people that just got here, I was plugging the Discord a little bit, and I had been asked a question right before you guys got here about getting Linux certs. I don't think you need certs. I don't think you need college, but they are positive differentiators. They are things that look good. Oh, Rob made you come here, Seabear. Nice. Well, here's some certs that you can get for free. They don't cost anything to study, and they don't cost anything to take. And then we have a bunch of events that are coming up. We've got one of our guys, Salty Catfish, who also streams sometimes. He's running the Code Cove every Sunday. And I tell you guys all the time, he doesn't just show you coding, right? He's been doing this for like 15 years, and he's been a lead for the whole time I've known him. He shows people how to be on a team and how to do your Git and how to pull your branches and all that stuff. That's what he does. So, oh yeah, and guys, there's all kinds of good free stuff out there for sure. Oh, and that's cool if you get a little penguin badge too. That's pretty good. We've got a sales engineer who is an engineer and pre-sales engineer from Red Hat. And looking at that, I realize people might be like, is he trying to sell us something? No. He's an engineer that's coming to talk to you guys about being in the field. So, yeah. Yeah, Rob, I was watching you, and like, it's funny, Rob, I don't even know, like, if you're back, like, if you're out in Utah still, or if you're back home on the East Coast. I don't even know where you're at. I know you said it was a real nice day out earlier, so I know you weren't in my type of town, because it was, it's hot here. I think it's 107. It's 105 right now in Phoenix, and it's only 246 here. So, but I'm gonna be in Austin all next week. I was telling you guys that, and then I'm doing a big 16-week Linux system administration course. I've got this whole course that I've been planning and telling people for years I was going to put together, and that's what we were going to do. But for today, what we're doing is Prometheus. We're going through, so I'll run through it real quick for people that missed. The Prometheus PCA study guide. This is a cert that comes from the Linux Foundation. They always have it on sale, so I got it for $175. I haven't taken it yet, but this is what the test looks like. You get a free retake with it, so I'm probably just going to do it sometime next month. And then here are the topics that you're doing for it, right? Which is interesting, and we're going over, we were still in the first one. But then we come down here, and here's all the things that you can do to start getting ready. There's free hands-on stuff. There's hands-on stuff in your own home lab if you want. There's just this cheat sheet, which I'm going to link this again for you guys because I think this is like one of the best things around. They've got a cheat sheet that shows you how to do your queries. And then when you click it, you're like, well, I want to see that query. It drops you right into a Prometheus instance with that query applied. So this is a real Prometheus instance. You can change these components here and say, no, I just want it right now. And it'll say, oh, I can't give you a rate over one instance. So then you go back and you say, well, okay, I want it over 15 minutes. Give me 15 minutes worth of that data. And this thing's always up and running. And they will give you the rate, right? The rate is the overall increase or decrease of it over the last 15 minutes. There's also an I rate, which is an instantaneous rate, which is the most recent. It's also funny because it's I rate. And there you go. Yeah, Isinga's good. I've seen some good stuff with Isinga, but I'm a big fan of this component. And then for people who want to know how I run it in my home lab, this is what my home lab looks like. You take any Joe server in my environment, he's got a telegraph agent, a PromTail agent, and a node exporter on him. Now, some of you guys also know me from when I talk about being in the industry. I hate agents on my boxes. I absolutely effing hate it. If I could have my Linux boxes at 0 agents all the time, that's what I would do in life. But it's so useful to have like a node exporter and a PromTail and a telegraph that I actually am okay with them. Yeah. So this is what I do in my home lab. I feed out. So this is like, I need to draw my little dotted lines here and say, this is my ingest tier. This is my aggregation and storage tier. And then this is my presentation over here with Grafana. So this is how we do it in the ProLUG lab. So I've had this drawing for a couple years. This is how we do it here. But I wanted to kind of do a little bit of a stretch and build out my Prometheus experience, so that's why I put together this training on it. So I have Ansible all over the place, Rob, but not specifically with that stuff. I have my deployment was in Ansible, so some of you guys that might care about this, hold on. Like so we were just, hold on, let me show you guys this real quick. We were just looking right now at, let's just cat this real quick. So here's our Prometheus YAML, and the last thing I was about to show you was this ProLUG lab scrape. Like, how do I scrape all of my stuff in my environment? And I use this file sdconfigs. This is like the little, if you want to think of it like a preparatory command. So watch this. So then I've got this JSON doc right here. So each of these, I should have put them in their own directory. I'm lazy in my home lab. So let's go look at like my, my whatever node. This is some node out in my environment. And he is part of the team dungeon, so he's one of my dungeon nodes. So a scrape is how we tell Prometheus what it can go pull from. So in this case, my Prometheus has a node out there, and the target is 192.168.103.9100, which is node exporter sitting out there on some server in my environment. And he knows, because of all of these configs, this is the scrape config component of Prometheus, but this can be any number of hundreds of nodes. In this case, I only have a few nodes in my home lab, but when I first did this, I did it here, but then I've done this for 1,260 nodes for a big college in the Northwest that I used to work for. So let me show you guys how, I was doing I was with my current company, but I was contracted to them. Let me show you how I build these. Because you might say, okay, so Prometheus is ready to grab everything that's in this directory. How did you do this? Did you build all these by hand? No. So watch this. So we'll go back over here to, let's just go here. And let's go to root streams. I think it's Linux code. Yeah, Linux. This is where a lot of my Linux stuff is because I push it up to GitLab internally. And if we look real quick on, where's my node exporter? This is a inherited role from node exporter. So we cd down into roles, we look in node exporter, and then in here we've got a Ansible Galaxy. This was an Ansible question, so that's why I went kind of over. So let's go look at, let's just more our tasks and our main.yaml. And this is how I build out when I want to go push node exporter to a node, but then I want to add it to my Prometheus. This is what I do. I go, look, it's a node exporter on the node, make the user, push over the executable, push over the config for the service so that the service will restart the service inside of systemd. So now node exporter will be exporting on port 9100 for my system. Now it's ready to be scraped. Once you have port 9100 open, Prometheus can come along like a little thresher and chop off that data every 10 seconds. So watch, this is how we do it. We go over to the Prometheus directory and we look for his scrape, and then we come down here and we build this file. This file gets built for the node that I just installed it on. There's his address. Yeah, there's his whole address there on port 9100, and he gets dropped into the Prometheus server right there, whatever my Prometheus node is in that directory. Boom. So that's how I generated all of those. See that Etsy Prometheus item.json? That maps directly back to this right here, which maps to this little thing that was created. So this right here creates this file right here. That's it. It's that easy. That works too, Kurosama. Or Kurzma. Yeah, that works as well. I like, there's a bunch of ways to do things, obviously. If in the corporate world, I will never, some of you guys know this, in the corporate world, I will never pull something from the outside. I will always pull it down, do it in my test environment. Now you say, well, you just pulled it from the outside. Yes, there. But then after that, I push it all the different places it needs to be. All right. So, again, prepping your hands-on environment. You got to get your hands on this stuff to learn it. So here are free places that you can go. They're hour-long blocks. You only have an hour. You only have an hour in each of these, so you build them and then you get ready to rebuild them, but that's still good practice. You can do a home lab. This is a little setup. By the way, guys, I just loaded this right at the start of this talk here. I loaded this up into the Discord under the presentation section. So if you're like, oh, that's a cool little presentation, but he's got so many links, it's right there. As ready to go as it can be. So if any of you are like, well, I'm not going to go take the cert for $250, but I will study it, then that's where you can go download it. And I tell you guys all the time, even if you just join our Discord and then you gather everything up and loot and then leave like a cartoon villain, I don't care. It's still, I mean, it's, as long as this stuff is useful for you guys. It's not like I'm selling any of this. The only thing around here that I sell is a book. I got a little book. I just published a new version of it today and it looks pretty good. But other than that, I don't do anything that's selling. Everything else here is for you guys, right? So we got down here. We're in observability, right? Seabear, am I currently working on the Linux beginner start here? No, I just have like 4 things in there, Seabear. I haven't really worked on that much. Like, I guess I could add stuff to it as I go, but I haven't really. You'll find, Seabear, that a lot of the times I just get on here and just throw stuff and hope it's useful to people. I don't do a whole lot of like tuning it down to really clean. But that's what I'm trying to do with the 16-week course. I'm going to try to have like a good, accurate and applicable course for everybody to just do Linux, right? Get your hands on it, do a few hundred, commands each time you get in there, and hopefully pick up a lot of stuff. All right. So we did metrics. We talked about these, right, earlier. We talked about logs, and then we got into tracing. We talked about how tracing works a little bit before people got here. And then we were on the push-pull, and then we got to the service discovery, which is what we were just looking at. That service discovery, how do we tell Prometheus what to go scrape? And I used Ansible to deploy that, and then go tell Prometheus, hey, here's all these things that you can scrape, and then it knows. And there's a whole bunch of different ways that you can gather these metrics. There's a lot of different types of exporters out there. Node exporter is not the only thing that can present up, and all of them have different ports. Again, this 9100 conflicts with Cockpit, which is kind of annoying, but there's only 65,536 total ports you could use. Well, you can't use 2 of them, the 0 and the 65,535. So, oh no, of course we got to run into each other. All right. So service discovery. Oh, did I already have that? Huh. Maybe I'll go take that other one out then. But this is how service discovery looks. You've got event-based, update frequency, format, transport, and security. If it's file-based, it uses iNotify, and iNotify is anytime a file's been changed, it'll let you know. It's based on the file security. That's where the security comes from for it. And then HTTP is not event-based because it's however often, every 10 seconds, that the polling comes around. It follows whatever the refresh interval is, which again is like 10 seconds by default. It's got to be JSON. You cannot do some other format, and you have to have HTTP or HTTPS. You can do TLS or any of those things if you're using HTTPS. So transport layer security, typically version 1.3, right? And then they have a link here. I put the link in there, but I mean, they have some good other information on it. All right, so then we get into SLOs, SLAs, and SLIs. There are different things that are important to know if you're going to be in the business of monitoring things. For me, I want to know, is my system up? That up-down check of Prometheus is probably one of the most valuable things to me because I just want to know, is my server up, right? Then I want to know, after I know that a server's up, I want to know if SSH is active, right? Can I hit port 22? Can I get a actual connection back, right, from SSH? And then maybe check the uptime, right? Those are things that I like to do. Well, if Node Exporter is sharing and I can just go scrape these things, that's pretty valuable to me as well. The way a lot of the older tools out there used to scrape is by SNMP, right? Simple Network Management Protocol, which most of us think of as Simple Network Monitoring Protocol, but it is a management protocol. You can manage a network with SNMP, although I would advise highly against it. Nobody does it. But when you use SNMP will still sometimes respond with old data, and a system can be locked up and still be giving you data off of it. So that can be a limitation. I haven't seen that yet with Node Exporter, but I imagine that could be the same with Node Exporter too, maybe. But we've got service level objectives. So we start with service level indicators. They are a quantitative measure of some aspect of the level of service that is provided. What's the latency on a request? What's the error rate? And is the error rate increasing on a system, right? What's the error rate over time? So this is that rate function that we were talking about earlier. Is that an increasing or a steady error rate? Because maybe an error rate of 5 per minute is good. Look, an error rate of 5 per minute on 5 million requests per minute is maybe acceptable for most organizations. Yeah. So, and then standardize your indicators. Make sure you have a frequency of every 10 seconds. Your data access latency should be time to last byte, if you're talking about how long it takes to access data. And then your aggregation interval should always be the same. Don't be averaging over 1 minute and then over 10 minutes and over 15 minutes and presenting that on the same dashboard. Never, ever, ever do that. Seabear said, did I learn Bash by just doing it, or did I have any type of education? I had one class in college, Seabear, and then I learned all my other Linux in the wild. So I would say I learned Bash in the wild, yeah. Yep, I would definitely 100% say that I learned Bash in the wild. But that being said, you just kind of use it as you need. Like, you spend as much time down here. I've told you guys, like, I literally work all day in this right here. I never go to a GUI ever for systems. All my systems work is always over command line. So over time, I think you get better at that. And you just got to practice it. The best way to get to doing this all the time, I use Putty. Yep. Putty's probably my favorite tool for that. I know there's all kinds of other fun ones that are out there. And then I use Screen, or sometimes I use Tmux, depending on the environment I'm in. But it's one of these things where I won't let an individual tool affect how I do things. But yeah, I use Putty. Yep. So service level indicators. Then we look at service level objectives. So we say, look at service level indicators from less than to upper bound, and then you have what your service level indicators should be within as far as your objectives. Your objectives should be above and below whatever thing. And then once we, over time, and typically a lot of this stuff is from good benchmarks and baselining of the system over time. Baselining tends to be just how the system operates all the time. Benchmarks are when we spin our system up, right, and put some performance to it. We push the gas down. But our service level agreements are explicit or implicit contracts with your users of how a service will perform against service level objectives. Can include consequences for missing targets. So in bigger organizations, sometimes we have things called chargebacks, and sometimes you have that stuff. Seabear, I have a fair amount of free labs that are out there, yes. They are all on Killer Coda, and they're all free. And I will link that for you guys over on YouTube as well. Although people on YouTube are being quiet. I haven't seen anybody talk over there, except for the Mad Monk. So, there's a bunch of things that you can read about to get... One of the things I did with this... Seabear, you can't tell me I'm a great man. Somebody said that earlier too, and makes me want to tell you guys this story. But anyways, don't tell me that. Yeah, same link. Yeah. So, do I have the same link twice in there? No, they're think they are. I think they're different. Oh. Yeah. Did I do... Oh, I probably missed some stuff. Oh, the one that you did, startup. Nice. No, that's awesome. In fact, did you guys know that there's a whole bunch of just free books out on Google? Google has free books. Like if somebody tells me, hey, Scott, I want to get into site reliability engineering, I'd be like, well, how badly do you really want to get into it? Because, like, I don't know if you guys know, but there's literally just... If you just go to sre.google, just sre.google by itself, they will try to turn you into a site reliability engineer. Did you guys know that? They're so interested in this that they will just give you free books. If you guys have never seen that, sre.google/books. Yeah, guys, they're you know, Google is big enough that they can just say, hey, we want more SREs because we need to harvest them up and use them. I don't know who, Cuddlingus, I can show you some things that are like site reliability well before Google was ever even thought up. But yeah, in general, I would say that they probably have claim to the SRE. Yeah, calling it site reliability engineering. There's a thing about this. I'm gonna bring up something that comes from somewhere else. A lot of people really like chaos engineering. And if you guys have never seen, so chaos engineering is site reliability engineering, but this is a guy named Dastragon put together one of these nice little GitHubs that show you guys a lot about, this is site reliability engineering at the end of the day. They're just looking at it the other way. Seabear, do they happen to have a Linux command line book or maybe Linux Bible book perhaps? No, but here's, Seabear, this is, let me stop this for a second. Let me show you guys something. I'm going to step over here for a second. My advice to get good at like command line would not be this. Look, if you want a good book for this, tldp.org will teach you all of the basics of command line that you could possibly want. I'm going to link this to you just so you have it. If you want every command and every useful thing that Bash can do, there you go. But hold on. I guarantee you that will be like eating chalk right there. That will be just the most terrible experience you could imagine. I wouldn't even know why anybody would eat chalk. But my point is, this would be absolutely atrocious. I couldn't do this. I couldn't just sit here and do hands-on from start to finish Linux for no reason. But you come over here to like Killer Coda, and you say, okay, I want to learn Bash, but I'm going to learn Bash as I go. Yeah, it's a little chalk heavy. Yeah. You're like picking it out of your teeth and stuff. But some of you guys want to be like LFCS, right? That's one of these Linux certs. Or you're doing one of these other Linux certs. Well, it looks like I'd never even been in this person's one. Oh, this Well, look at this. He's got all of these Linux ones on just doing Linux. So you're doing all this other stuff, but you're learning Linux or Git right here. He's got some pretty good like a Git rundown of how Git works. But the whole time you're going to be doing Linux commands in Bash for the purpose of learning Git, if that kind of makes sense. So I kind of feel like you're going to, let me use my example of a gym for a second here. If you have two buddies and they're all getting swole up in like high school and you're in high school or college and your buddy's working out all the time and you say, hey, I want to be like you guys. And then you go and you say, well, I want to be like you guys. I guarantee you none of your friends are going to sit you down in the gym, like in the locker room for 6 hours and explain to you about the gym. No, they're going to be like, let's go. And they're going to make you follow them around in the gym. And over time, you're going to be like, well, today this hurts and oh, that hurts. And then, oh, I guess we were pulling a lot the last few days and now my back hurt, right? And over time, you're going to figure out what's happening. I think that's a more effective way. That's the way I like to learn, kind of being drug along. So where I'm going with that is go start saying, hey, I want to be a site reliability engineer or a DevOps engineer. So I'm going to start using CKA. CKA, look, there's 100, he's got 130 different scenarios here. I think 120 plus. But you can go in here, and as you're doing it, you're going to pick up all these other pieces as you kind of learn the things. I have purposely not went to any of my labs on here. I showed you guys my labs earlier, But I have labs down here that you can go and spend as much time as you want in that focus on doing Linux. Look at, man, there's all these things out here. All these people trying to show you all these things in free lab. Every lab on there is free. Nobody's going to charge you nothing for it. All right. Anyways, all these books to get better and all these things to get better with Prometheus. And look, I'm looking at another one here, Prometheus. And this one talks about pusher, pull doesn't scale or does it, and then how you can figure out how to do things. This is back to that Isinga. I think Isinga is a form of Nagios, but I'm not 100% sure of that. Like I think it forked off of Nagios, but maybe I'm thinking of Zabbix. One of those two did. But they've got all these things, and then they talk about it, and they break all these things down. So you can go spend more and more time with all this stuff, too. Yeah, Cuddlelingus, Fisherman's Labs are great. What about the man command? Isn't that pretty good to learn what commands and examples and use them inside terminal, try and find out what's next? Yeah, Seaberry, the man command is great. Like, if I'm trying to do something with date and I don't remember the exact way to format the output, yeah, I'll go read the man pages on it, right? I think man pages are great. But to just say, okay, I'm going to sit down for 2 hours now and just read through all the man pages of all the commands I know about, I don't think you're going to learn nearly as much as if you say, okay, well, I'm going to go do, let's just say, for example, my monitoring labs, and you go do the monitoring, and you don't even think about it, but you were doing wget to pull things down, and you were updating the system and installing things, and then you built out all this monitoring, but you were doing all this command line stuff as you did it. I think that, I mean, this is maybe just me, I think that absorbs better. Yeah, the TLDP is, I think it's great for like a reference guide. I use it as a reference guide. All right, so anyway, so let's go look at system architecture. How do we configure and do our scraping? What are some of the Prometheus limitations? Like, why do we do push and pull? And then data models and labels. This is huge. Understanding how to query down those labels are big. Chaos engineering is very similar to site reliability engineering. They're the same thing. Chaos engineering is the idea that I ask a question. I say, well, what if I just take down, like, what if I just, there's a little arm on this microphone right here. I got a little arm. I go, well, what if that arm was missing, and then I just break the arm and it falls, and I go, well, I probably should have thought that would happen. But what if I had two arms that were coming up, or like you have 2 or 3 pods back-ended from a service, and you go, if I take out one of those pods, what happens? And you just kill the pod off. And then you see what you expect to see is that in a service, like if you have a deployment inside of Kubernetes, the deployment has created its what are those things called? Replica set. And then that replica set desires 3 pods. So you killed one of the pods off. The other 2 were still endpointed, right? Those were still endpointed from the service. A new pod was built, and that got connected. And you see that happen, and you like hold it in your hands, and you go, oh, I get how that service works. That service just points at whatever pod is under the label, and the deployment is responsible for the replica set, and the replica set is responsible for making the pod, and it like clicks. But you got to see it happen for the first time. You got to see it kind of like happen like that. So, disgruntled driver, hey, how's it going? We are doing Prometheus Certified Associate, and I'm kind of going off on the rails all kinds of different ways like I do. Okay, so here's the system architecture. We've got some node with Prometheus running on it. It's a time series database. That's what it's doing. It's got an HTTP server that we can hit, and all of those API calls go back to a log somewhere. That time series database is doing things and aggregating and pruning down data that are being sent to it. The retrieval here is either scraping out like service discovery from things that you've configured, like those little scrapes that I was showing you guys earlier in here, right? All of these little scrapes are telling Prometheus what to go retrieve, and it's pulling things out. There's also possibly a push gateway where things are being pushed, and then we're retrieving via pull metrics from the push gateway. I have not set a push gateway up yet. I need to do it one of these days. But I just know that it's sitting there and it's getting scraped, and then that's pulling down. By the way, here's the other jobs and things that I'm pulling, which you can configure as many of those as you need. There's all kinds of them out there, right? PromQL is as you come in, you can do the Prometheus web UI. You can have Grafana doing queries, and you can have API clients pulling data out of Prometheus as well. And all of that can be secured via certificates if you want. And then you've got, with certificates, you've got layer 4 transport layer security. With transport layer security, you have validation that they are who they say they are, communicating into a server that they should be able to communicate into. And that server will not give data to other people who don't have your appropriate public key. Now, you guys have heard me say before, public keys can be shared far and wide. Sure, but if you only share public keys with people that are supposed to, and this is zero trust stuff, if your public key is treated privately, like you keep your public key safe, you can use it to validate that only the people who should talk to something can, right? And you guys have heard my whole stick on that, but I'll bring it up again because I think it's an excellent tool for you guys. If you want to know more about zero trust, you go to this site right here. This is a free book out there. It is 100% free, doesn't cost you anything. It's called Solving the Bottom Turtle, and it deals with how zero trust. So if you've heard a lot of people running around going zero trust, but nobody's telling you what it is, this is a free look. It's written by these guys in 2020. It's licensed under Creative Commons, so you can show it to people and you can share it, but you have to keep all this stuff with it. And Hewlett-Packard helped sponsor the book Sprint as part of a contribution to the open source community. Some of the people of our community are here listed, and they helped to do this. And you can go read about this. And this is excellent. They've got a really good, I always hammer on it, page 41, right? Some of you guys are like, oh God, he's on page 41 again. They show you how certificates work. If you struggle with certificates, come in here. They'll show you how certificates work. So there you go. Free is one of the best prices out there. Dr. Dead Click. I think that's one of the best things out there. But even if you just start out and you go, okay, well, let's just see what the start of this is. They've got a really good explanation of the traditional way that we protect it. So this is really how we used to protect servers. We'd put a big, strong outer wall. Let's call that wall Maria. And then we have our stuff sitting out there and partially out exposed in like a DMZ so that we can hit it and we can hit it, but then everything else is protected, but everybody can talk in here. And what happens when the Titans breach that outer wall? We'll call it Wall Maria. Is that safe anymore? No, everybody's getting munched on by Titans, right? Anybody know what I'm talking about? Somebody knows what I'm talking about. All right. In the modern way of doing things, I was a big, I read all the manga. I have all the manga from a Humble Bundle years ago. It was great. Now in the modern way, we don't have that big, strong outer wall. We allow things to connect, but now everything talks to each other with those certificates, right? Oh, the manga was so good. The manga was super fun. All right, so anyways, you guys can read about that. I think that's a great way to spend your time. But this is the architecture. And then a thing that I still need to set up a little more is push alerts. So Alert Manager can be used to push alerts out to PagerDuty or email or notify, even like a web API. You can use this to send alerts out, and then those alerts can be picked up by whatever you kind of want to do. So you have a pretty straightforward way that this all works. And all you got to do is go build your little Prometheus server and start building the pieces of it. All right. Mostly what I've done is all the poll metrics. I have all of the PromQL stuff obviously going, but I've never set up the alert manager or the push gateway part. That's things I need to do. So scrape configs specifies a set of targets and parameters describing how to scrape them. We do define them within a configuration file or a wildcard of a bunch of different configuration files, which is what's said here. There can be static or dynamically assigned. And then there's global defaults that apply to everything, and then they can be overridden inside the scrape. So scrape interval is whatever duration, and the default is 1 minute for the overall, but down in each individual config, you can change it. So in my home lab, let's go look at this again here. Let's just cat the Prometheus out. Any defaults I have are up in here. So the scrape interval is 15 seconds. The default is every minute, right? but I have it set to 15 seconds. But then if I come down here, in any of these configs here, I can override that scrape interval if I want to. So let's say it makes sense in my environment to leave it at the default of 1 minute. But I want what we call a higher resolution. I need to know within 6 seconds. Maybe my service level agreement has to deal with down every 10 seconds or so. So I need to know like every few seconds, maybe every 5 seconds, that the service is active and within my numbers. Something like a minute is not acceptable. If my service level indicators are down at like a 10-second rate, but I'm only grabbing every 10 seconds, that's like... It's like if you ever seen, like, I don't know if any of you guys ever played the old game Metal Gear, but like the guards would walk around and there would be these big gaps and you could just like walk through. Or you could just go murk the guards and pull them into the darkness if you wanted to. M-E-R-C, murk. But anyways, my point is, you can override things because maybe for these guys, I need it to be more precise. And look, I know my home lab is a pretty small little example, but I'm still scraping the things that I am, and I can go and configure them, and we can know where any of these other things are. Seabear, you said, what distros do you suggest I start out on? VMs, Ubuntu, Mint, Fedora, Rocky. I want to build my own virtual lab, but I don't know where to start. Is there a lab video? Okay, so I tell people, like, if you want to run like local stuff, you've got a laptop and you just have to run your own stuff, I would use like Oracle VirtualBox. That's a great one for people who aren't running. You can't run that within an organization. You can cost your organization money, but for like home stuff, that's free. If you have a little bit of hardware, you should run something like Proxmox, or what I use in my home lab is XCPNG. And then I've got, these are all nodes here inside of my physical boxes that sit behind me in a little half rack, right? And then I've got all this, like, here's all my Rocky stuff and my Werewolf and all my different nodes doing whatever they're doing in my environment, right? In fact, my Prometheus node that I'm on right now is right here. Where is he? There's my Prometheus node right there that I'm looking at right here. And we could prove that. Watch, we could go here. We can go to his console, and we're actually logged into him, and we should be able to say echo hello stream to wall, and that should pop up over here. See? Oh, well, don't mind the W there. Don't worry about that. Yeah, VM workstation. Yeah. If you have to have your own stuff, God, hello, it's so embarrassing. Let's just pretend that never happened. We'll edit it out in post production. I'm just kidding, but here's my Prometheus, and then here's all my other stuff that's doing stuff in my environment, right? I even got some nodes that are off that I'm not doing anything with right now that I probably should one of these days. But back to the scraping, we can scrape all kinds of things. We can set up configs. We can do all that kind of stuff. Yeah, clip it and ship it. Yeah, Quartz. I've tried to get it going where there's like a bounty on good clips of me, but like, I get people are doing other stuff. For the most part, I'm just happy anybody's watching. But, I know for a lot of times, like, I know my brother's always on, and then he's just got it, like, in the background somewhere. So, at that point, it's really just, I'm glad people are hanging out. But, all right, so let's understand Prometheus limitations, right? The long-term support, there's a 10-year cycle. Every 6 weeks, a new minor release begins. So I probably have to update mine because I haven't updated in a long time. There's some local storage limitations. It's not clustered or replicated, so it needs to be treated like... I must have left that out. It must be treated like... Hold on. It must be treated like a disk, right? Like you've got to back that up in some way. That's kind of on you. Compaction happens in the background. It's initially 2-hour blocks and are eventually compacted into longer blocks in the background. And it's 10% of data retention, so however much data you have, or 31 days, whichever is smaller. And that's all configurable. No, Prometheus is just a time series database flying 4x4. It's not, by default, it is not a SIEM. And people that are wondering what is a SIEM, it is a security, information, and event monitoring, right, tool. But no, it's more of it's just a key value database in a time series database format. So Yeah, and then we query it like that, and we look at it in time series fashion. I would plug like Loki much more into like a seam idea, although you need something else alerting or querying off of Loki as well, which you could use Grafana for. You could build again. You could build your own seam. Alternatives to like Prometheus, you can use. Here's some alternatives. So Prometheus in my environment as a time series database is grabbing data from Node Exporter every 10 seconds, but an alternative would be Telegraph feeding data up into InfluxDB. InfluxDB is also a time series database, and then Grafana can query from InfluxDB. So an alternative to Prometheus might be InfluxDB, and there are reasons to use or not use it based on what you're doing. Like Prometheus is the standard if you're doing stuff with Kubernetes. Like if you've got Kubernetes and you want automatic service discovery and you just want to point this at your Kubernetes and then expose from like a Kubernetes standpoint all your metrics, you can do that like in a few minutes. There's 100 blogs online that'll teach you how to do that. So Prometheus is like the de facto standard for that. Whereas like with InfluxDB2, it's a time series database that's sitting there. It's secured in the same way any database might be, but you might need to have some different agents that are tooled to do that. So whereas I think InfluxDB is awesome for just servers with Telegraph and all these different things that you can aggregate, Prometheus is the king when it comes to like Kubernetes and stuff. That's probably why it's so popular, because Kubernetes is so popular, and it's the best. It's there. Other than that, though, I mean, I guess you can use SNMP. You can use SNMP would be then any of your Noggeos or your Zabbix or what's Science Logic use, some kind of bullshit. Science Logic uses some kind of, I forget what their app is, but it's terrible. Oh, nice. I didn't know Proxmox exports to Influx out of the box. That's pretty good. All right. How do I get good as infrastructure as code? Is there any killer code-type website or project where I can learn production-grade Terraform or Ansible? Root, I would say I have some pretty good Ansible stuff. Well, I think it's good. Up on Killer Coda. Terraform, I have some really basic stuff with Terraform. I moved away from Terraform back with the when they did that shift of their licensing before they got bought by IBM, which I realize is ironic because Ansible is owned by Red Hat and Red Hat's owned by IBM. So it's like the two kings of the industry are both owned by IBM. Yeah, I like my Ansible stuff. I'm a little biased though because I've been using that for so long. One of my things about Ansible, it's funny that it says answerable because that is where the term Ansible comes from. That's neither here nor there. I do really simple things well, and then they build out into, and they scale all the way up with Ansible if you do it right. So, like all my stuff on there, you'll be like, oh, this stuff's super simple. I blew through it all in like a weekend. It's true. That's all I do. What I showed you guys there. I figure stuff out and do other stuff, but my point is, the basic logic of all the things you have to do to be good at Ansible in the industry, I think, is there. So then you just have to spend time with it. All right. Data models and labels. So we have metric names, and you can specify a general feature of a system, right? So you should have HTTP request total. And then we have metrics labels, so that's going to allow us to select different pieces of the data model to identify any given combination of labels for a metric name, right? They allow us for filtering things down based on dimensions. You can't use some of these characters, so you can use these ones. You can't use 2 underscores. Those are reserved for whatever. Yeah, Terraform is, yeah. There's some common notation. You give a metric name and then a label name equals whatever. And it might just be easier to see that than this. So example might be API HTTP request total, method for posts, and handler messages. So let's go look at one of these real quick. Let's go pull up, if you did it earlier and you pulled up this PromQL thing with me, right? Let's just go look at an example of this. So right here they say the notation is metric name. Here's a metric name right here. And then it says label name equals whatever the value is. So right here, here's the metric right there. And here's a label equals 0. So this will only be gathering CPU 0 only in mode idle. So we'll look at that. And look, here it is. Here's the metric name, node CPU seconds total. Here's the label name equals, so CPU is the label name equals 0, mode is equal to idle. And it gives us that value. And then I say, you know what? I want CPU 0, but I want to know all the modes that it could be. I pull that off and I hit enter. And now I see that CPU 0 could be in idle, IO wait, IRQ nice, soft IRQ steel, system, or user. Those are the options it can be. You see that? So then I can go and I can look at all these, and I could maybe guess that all of these add up to 100, or I can go actually try to add them up and see if they hit 100. Looks like they're going to be over 100 if I add them all up. Yep. But I can go and maybe I care most about system and user. So system and user and maybe idle, right? So then maybe I come here and I should be able to say mode is equal to, and I should be able to say idle or system or user, right? Like that. Oh wait, did I not do that right? It might be when you do this, you can't do equal, you have to do like those. Is that not right? Mode is equal. Yeah, sorry, the tilde has to be after. And then now, whoops. I think that's right. Mode is equal to idle system. Let's try this. Hold on, idle. Oh, it's because I got the comma wrong. That's my fault, guys. You got to put the comma back in if you're going to do that. And then I could just see idle. And then I can say or system or user, right? And then now I've got all of those. So now I'm querying out idle, system, and user. And then I can say, give me all those for the last 5 minutes, right? And then now I've got this series of data for the idle and the system and the user, and then I could turn that into, in this case, maybe like a graph over the last 5 minutes. And I can see there's all my, what is this one? This is, I'm colorblind, but that looks like system down at the bottom, and then node idle is way up high, and then user's this one here. Oh, look, it highlights them too. Look at that. It's nice. All right, so there you go. And then maybe you want to see the change in them over time. There's all kinds of things we could query, right? But the point is, that's what we're showing here for the common notation for how you call the labels up. Here's some best practices of naming if you want to go spend some time with that. All right, so exposition format. Simply put, exposition format is a text-based format if you want to export metrics, but your preferred language doesn't have a client library for you to use. So if you wanted to do your own export for Prometheus to come scrape, you can write a text format out and then just post it somewhere in a on a port that's being able to be scanned and read, and then you could read this. So look, this comes from right here. If we were looking at like HTTP requests, we can go here, and I can just, on this box, I can just curl 127.0.0.1 on port 9100. Whoops, 9100 metrics. Is that right? Metrics? Yeah, there we go. And then there's all my metrics for my system. So if I happen to say, well, what if I wanted to grep for, I don't know, prom HTTP? There's all my prom HTTP key value pairs that come up through the whole thing. All the comments are ignored on the scrape, and all of the other things are just key value pairs. So here's key value pair. Prom metric handler request code 200. I can go look that up. So I could grab that right there. I can come back over here to my home lab version of this. So I have my own Prometheus here, and I can go grab this, and this should be the exact same thing as what was seen on this node. So this was 127. This was my local one, right? So this was my local host one right here. That should be the same number, 2715093, 2715089. So it's pretty similar, right? Yep. Those are a counter. That right there is a counter because it's total, so it's always incrementing, right? So it was 89 here, and it was 93 by here. So there were 4 added to it, right, before it got to here. So there you go, boom. How's Ranger doing? That dog. All right, I don't blame him. It's 106 outside, so I don't blame him for not wanting to go outside. So I added this one from the last time we talked about this, but push gateways are always used in as limited a way as possible. The problem with them is if you're monitoring multiple instances, you can have, it'll be a potential bottleneck. It's a point of failure. If all your applications that are pushing metrics to a push gateway and this push gateway happens to go down, or the network in between goes down, your push gateway is not being scraped, so that data is lost forever. Because remember, Prometheus only adds data if it can scrape it. So if Prometheus can't get to this for 4 hours, you've got a 4-hour gap of data. That's not good in some cases, right? Normally, Prometheus goes like this. It just scrapes from an app. But if you're doing push metrics, they're going to go to a push gateway, and then Prometheus is going to scrape it. You do lose Prometheus automatic instance health monitoring. So again, if I'm scraping from a push gateway, I'm not seeing that application is responding to me in real time, right? There's no check. Are you up? Are you up? Are you good? Are you up? Like, that's what Prometheus is normally doing. That's gone. And then visualization with Grafana. There's another one. Push gateway never forgets series push to it ever. So if you push data just even as a test, it's going to be there, and it's going to be in your instance Prometheus, or your Prometheus instance, until you go and you delete it by hand. You got to go in and do actual database commands against Prometheus to delete those. So that's something to think about. You got to use like a Prometheus CLI to go prune that out, and that's a hassle. So push gateways always require, a scrape still from the Prometheus instance. Nothing pushes all the way into Prometheus. That's not how it works. It pushes to a push gateway, and that gets scraped. So Prometheus only scrapes things. That's an important thing to know. But things can be pushed to a push gateway, which can be on your Prometheus instance, and then you scrape them yourself. All right. Digging deeper, there's some exposition formats. There's some storage topics. You want to go spend a little time with the storage. Look how the storage works. There's some graphics in here about how the disk layout works, and you can go look at the actual data. So like if I was on my system and I wanted to see, well, how are the data laid out here? Well, I would say systemctl cat Prometheus, right? And here's how my system was called, and here's my storage path, varlib Prometheus. Here's my time series database retention time, 31 days, because by default it was 15 days when on this version of the server. So then I maybe ls-l in varlib Prometheus, and there are all of those blocks right there. And I can see that they're being written every 6 hours. Is that right? Oh no, they're longer than that, because they're not every 6 hours, because they're every few days. So they're every more than that, right? Based on the activity, and then they're being chunked down. Actually, I take it back. These ones here, yeah. So those ones are being pruned down. That's why they're like that. These ones are every 2 hours. Yeah. And then some of these are probably being copied back and then pruned down. That's probably why some of these are duplicate like that for the time. Probably one of these is doing pruning and aggregating them up and then knocking them back. But yeah, then you start to get to 6 hours going back, and then you get over a day. Yep. Interesting. All right. So we see that it does those things, and it aggregates that time as it goes further back. You can go read about all that stuff if it's interesting. I think that's valuable. All right. So now we get to the PromQL. How do we select data? What are rates and derivatives? What's aggregation over time? Aggregation over dimensions of things? Binary operators, histograms, and timestamp metrics. A lot of this stuff probably is kind of intuitive if you do anything with computer science now. but then let's go look at it. So expression language is, there's instant vector and range vector, scalars and strings. We can match labels, like I was saying earlier, exact labels, not that label, so anything other than that. We can select labels with a regex max string, which is what I was doing earlier when I was doing that OR, and it was all of idle, all of system, or all of user. And I can say not those ones, only the other ones. So you can gather all of these types of data. To practice this, again, you pull this little guy up and you go start looking at these different pieces. Then there's functions and other stuff that we'll get to here in a minute. There's all the list of all the functions out there. Look at that. There's so many functions to use. But there's all of these things to go and practice and spend time with, right? Then selecting data, you can return all the series with a metric, so HTTP requests. So I should be able to go over here. I think this one will have it. Let's just open this up. And since we're looking at our own Prometheus here, our own Prometheus instance, I should be able to just type this in, HTTP requests total. It's a counter. I see that it's a counter, meaning it's going to be going up or down at any given time. Well, always. And this one should be, and what that's called monotonic, right? This is Prometheus HTTP request total. Apparently, I'm not just going to have a HTTP request total. It's going to be a Prometheus HTTP request. Whoops. Right? And here we go. And then now I see my code 200s. I see handler healthy. I see 200. So I got a lot of 200s. Do I have any other things? Actually, here's a good question. Can I say right here, I just asked a question. I said, could I get any code is not equal, not equal to 200, right? I want to see if there's anything in there that's not a 200. There we go. I've got some 400s, a 302, and a 503. 400, the client messed up. 500, the server messed up. 302, we redirected somebody, right? That's, by the way, that's one of those things I think you should know is your HTTP response codes. I think engineers should know those. All right. Oh, and we could keep adding to this. So let's go back to here. And then the next question is maybe the job is we've got codes and handlers and instance and job. And these jobs are all Prometheus. Are there any other types of jobs? I think in mine I might have done my home. But let's go see if there's any API servers. So I'm going to do the metrics again. I'm going to say job is equal to API. Is there any API server? There might not be. But in my home lab, I'm pretty sure there is. So what if I come back here to the... Here, let's go to this one. And then in here, I say HTTP. Whoops. Ah, no one wants to do the same Prometheus one. I could have sworn I had just an HTTP request total. No, I don't. Okay. But then I would go search for a job, and I would be able to query down by these different metrics. Again, you might want to just look at all the data and then figure out what you want to query down to. So there's that. You can look for job like a server, or you can put those OR functions like I was doing. All right, rates and derivatives. There are many functions that deal with the change in values during a certain set of time.rate or irate, and deriv are some of the functions that can track changes in a metric value. So rate will show you over time if there has been a change in the number of requests for like an API server. So like a per second average rate of increase in time series of a range vector. So over the course of 5 minutes, this will show me if it's gone up by over that time. The rate has gone up let's go look at it. How many requests there are. Let's go look at it real quick. I don't know why I don't have that other thing. Yeah, I'm going to have to use Prometheus on this one. And then we'll take that whole thing and we'll wrap it in a rate. And we'll say over the course of 5 minutes. Oops. We got to find one job. So we'll say like that'll still be wrong because there's only, let's do one handler. Let's just find one handler. Equals, let's just do like this one here. Comma. There we go. Handler was there. Job was Prometheus or query range. I don't care about the code. We shouldn't need a space in there, but let's see if we can just grab the query. See if we can just do the query. That works. Do we need... yeah, it's got to be out. That was my fault, guys. I was breaking that myself. The query has to go around. So if I do rate, it has to be around this whole thing. So if you guys didn't see, I had it at the end. I didn't have it all the way to the end like that. So the rate is going to gather all of this up. And then now there's no rate increase over the last 5 minutes for those queries. But maybe if I go over like the last 5 hours, maybe. Nope. But is there an instantaneous rate increase? Like just recently? Nope. Nope. It's been about the same. So this is where you can really get in and start to like dig into this kind of stuff. All right. So per second average, and then this is a per second instant rate of increase, as in it just changed recently. So sometimes, so if you have a rate, right? So let's say you're looking at like CPU, and CPU spikes, but you only have like the rate of the last 15 minutes. A spike isn't going to change that rate very much, because a spike is only going to change. It's going to change, instead of being like a rate change of going from like 60% the whole time to like 90%, you're not going to see that because your rate is going to be looking for the last 15 minutes or whatever you're looking at. But if you use an iRate's always going to use the last 2 examples. So what that means is if you're looking at an iRate, you'll get the 60 average, but if you get a spike of like 90, it'll say, hey, you've jumped by 30%. We've got a problem. That's a massive jump. That's a massive spike. So rate is like a long-term aggregation, like over a sliding window. And iRate is the same thing unless there's an instantaneous change right at the end. And that one is very useful for us as systems engineers. In fact, I learned about iRate. Should I DOS you so you can get some useful change? Oh, yeah. And then deriv is you need at least 2 samples within a range vector. It's designed to show change, not a steady bad state. So if you are sitting at like 90% over the last hour and nobody's responded, deriv won't help you one bit, because even though 90% is bad, deriv only cares about the instantaneous change as well somewhere in your system. Not typically reported on a dashboard. It's more of an alert idea. So the deriv function shows you an instantaneous change as well, but anywhere back in data. So you can look at that, play with that. Yeah, if we see in the last 5 minutes a deriv greater than 5, meaning you've changed, then because what deriv is looking at is moving off of a mean, right? Oh, wife's calling me. Give me a second here, guys. Hey, wifey. Sitting here talking to all my best friends online. What are you doing? Okay. I know I'm not muted, guys. I know I'm not muted. Yeah, I mean, you can bring it by now if you want. Yes. Two's fine. I love you, bye. Oh, I know I wasn't muted, guys. I can see it right there. I can see I wasn't muted. She was just at a friend's. She was cutting hair, and she does, like, when I first married my wife, she used to cut like 300 people's hair, and she was always busy doing hair. But then she scaled it back to only like her good friends. Yeah. Oh, I didn't care about the voice. But the thing was, one of her friends that she cuts her hair, she always makes her salsa. So she's got this really good salsa. And then she's like, well, do you want me to go get like some cheese quesadillas from Pollo Loco? And I was like, yes, gosh. Normally I do the old, what's that movie? Napoleon Dynamite. She'll say like, do you want something? I'll be like, yes, gosh. That guy's such a dork, but it was so funny. That was a pretty funny movie if you guys haven't seen it. And it was funny too because it was only like $35,000 to make that movie. It was like nothing, and they like did really well. They made millions off of that, and they made careers off of that, which is worth way more. Okay, so rates and derivatives, right? Aggregation over time. We aggregate over a single instant vector, resulting in a new vector of fewer elements with aggregated values. So CPU usage over 5 minutes is it's an aggregation. We can sum up CPU by looking at the rate of the node CPU total seconds. So we can actually pull this down, and we'll look at this real quick. And the mode if it's not idle. So we'll get all the things, and we'll see how much CPU usage we have out of the system. Then we can get all the statuses of 500 over the last 5 minutes. So all the errors, which are 500, which is our server-side errors, not 400, which is clients being dumb. 500 is our server being dumb. And we can find out all of that, right? And then we can aggregate it up as path or whatever we want to call it. And then we can get the total number of ingested per second average for 1 minute window. So how much work is our Prometheus doing, right? Here we go. So we can grab these. Let's go grab them. Let's do this in real time. By the way, guys, this is up there in our Discord. So if anybody needs our Discord, yeah, there's our Discord on the Twitch side. And here it is over on the YouTube side, right? And yeah, speed. Not speed. I'm trying to make stuff that's useful for you guys, right? Try to, get people in here doing this stuff and seeing that you can do it. Let's make this. Let's figure out if I can fit this window where I'm not losing my mind here. Let's go. That's fine. Let's do it like this. Do it like that. All right. So we're gonna sum by CPU rate, and inside the rate we're gonna get the node CPU seconds total. See how it's trying to help me out there? It's like, hey dummy, I'm gonna help you out. Yeah, Mint, we could do any one of those 500 or 400. Yeah. We can say anything not 200, give it back to me, and it'll tell me all the ones that are bad. Yeah. So there's different ways we can do it. Okay, so right here I need to do, I'm gonna grab with a curly bracket, any mode is not equal to idle, right? I'm gonna close that down. I'm gonna say over the last 5 minutes. And then I'm going to close that up. So 2 of those times 100. And if I do this right, and we execute, wait, what did I miss? Total mode equal to that. 5 minutes rate, sum by CPU. No, that should be right. That should be right. That should be right. Where do I have a square bar? Oh. Oh god, guys, you gotta stop me sometimes. Yeah, there we go. That was my bad. So now, over this node CPU, I've got CPU 0, 1, 2, and 3, and I've got their overall CPU seconds. Now, for which node is this? Oh, by the way, we can graph that. There we go. Boom. That's how our CPUs are doing in our system, right? But I should also be able to come over here and go, why is that by... Oh, yeah. So that's across all of these. So we have aggregated down actually over all the node CPU seconds that this knows of. So if you ever want to see like where is this raw data coming from, you can strip all this off and just go look like this and see, okay, that was 155, 155, 155, 155. So this was all, yeah, 156. So these were across all the nodes in my cluster. And you say, well, how do you know? Well, because this is the raw data right here. This is the raw data that thing just queried. So this was against all of them. So this was not against one instance. You say, because I was looking at that going, wait a minute, this is a new set of data, but the data are across the whole of my cluster. So what if like for me, I have my infrastructure nodes out here and I have all my CPU nodes and all my GPU nodes in a high performance compute environment? Well, I can aggregate up all of those where my metrics are for the CPU, and I can tell you exactly how much CPU across my whole cluster is being used, and exactly how much CPU against my GPU nodes are being used, and then also my infrastructure. But infrastructure nodes, or what we call like our management nodes that are outside of the cluster, they're just kind of like support that kind of like keeps the cluster going. They're like all the people that don't play basketball or don't play soccer or football or whatever you want to call it. They're all the people that are out there helping, but the individual compute nodes are like the players, and they're the ones that we really care about how healthy they are. You've never heard somebody say, well, the coach isn't healthy this week, let's hope the game goes good. No, you care if the players are good, right? Because they're the ones that are actually doing the work, and that's how compute nodes are too. Compute and GPU nodes. Sometimes we got some other types of nodes and stuff like that. But all right, I'm gonna pull this up right here. Yeah, so we could just keep grabbing these rates. Look, status is that or status is not that, and we can get all of the 500 errors or whatever in my system for the last day or whatever. Whatever kind of queries you guys want to do against your system here. Okay? But aggregation, this is important to know, you get a single instant vector resulting in a new vector. So I've got a new thing now with the CPU. It is not in any way now tied to these individual. Nobody can go to my CPU metrics and see these raw metrics ever again. They can go query the raw metrics. They still exist in the database, but I have generated a new type of vector. There's a new set of data that are available for people to go use now, if that makes sense. It's very important. Probably one of the most important things about that. And because you might say, well, why is this important to know? Well, because I may want to sum things up and then only show like a high level status report. Like I tell you guys all the time, I crawl down around in the engines of servers, right? Like I'm down in the server rooms, like I'm doing stuff. Management doesn't give a shit about that. Management cares how overall used the cluster was over the last 30 days. And then another thing they care about is if there's an error, but if there's no error resulting in from like a high load or something like that, they could give a shit about your individual node metrics. And that's fair, right? Like, what does a king care if some bathroom in some barracks of his infantry soldiers is actually clean? He doesn't care about that. Now, his individual sergeants and people may, because they want to make sure that their soldiers are whatever, but his job is to look at the big picture. Do I have 5,000 soldiers ready to, stave off the barbarian hordes or whatever, right? I don't know, whatever. But the point is, these things. All right. Aggregation over dimensions. Now, you can pull things in by summing up all of the requests, but then you can also pull out only the labels you want. So there's two ways to do it. You can get all the labels. You can exclude some, like take out instance, or you can get the same effect. So if I say application and group, well then haven't I left out instance? If there's only 3 labels total, application, instance, and group. You can get them all like this. You can say, well, I want to sum this up, but without an instance. Go ahead and leave instance out. And then it'll just give me the information I want from HTTP totals. Or I could, another way of saying it would be inclusive. This is exclusive, take out instance, give me the other 2. This is inclusive and leave out the other. But these both net you the same thing. What I've noticed during the last few years is an interest in having resources max out all the time to justify the total cost of ownership. application sharing usage and the downtime to an app trigger other. Yeah, startup me, I can tell you, working in high performance compute, a lot of times we do want to try to keep systems over 70% utilized. You might say that seems high. Yeah, I mean, as long as you're able to handle your base workload, let me give you guys a little bit of unclassified things that you can know about NOAA. NOAA is the National Oceanographic Atmospheric Agency. I built out in 2020. I built out their most recent supercomputer, which is going to be running until 2031. I think is how long this one's going to be running. That I built. I helped build it. I did all the Ansible for it, all the stand up and all that stuff. The workload on that system looks like this. There's a Phoenix and a Cactus and Dogwood, Phoenix and Manassas, Virginia, and you can go look that up. That's all public knowledge. One of them is always running as primary. The other one is secondary, always ready to run. The primary one runs the ingest of NOAA. If you don't know, is there are over 2 million sensors a day that feed data into NOAA. That's National Oceanographic Atmospheric Agency. There is data always being fed in from all over the world to NOAA, from government, civilians, military. Literally everybody out there feeds data up into NOAA. And it churns through a workload every 6 hours. Every 6 hours. So 4 times a day, there is a product of whatever the weather is going to look like in all the regions or whatever, right? And that's all stuff that's D-class. I can tell you all that, right? Where I'm going with that is, so that's the primary node. The secondary node is sitting there idle. And they have a goal to use it at a certain percent. I want to say it's like 70%. Even though it's the backup node, even though it's the secondary node, if the primary node ever couldn't fulfill its 6-hour duty to run through that stuff, the secondary node has to, within that same time block, all the other time's already wasted, still get that piece of work out. So everything needs to stop on it, and it needs to run the jobs, right? And that's a function of how they've chosen to do it. And by the way, last I checked, it gets done with it in like 15 minutes. So it's 6 hours worth of work, but it's done with it like that. So then it's got all this idle time, and then they're trying to fill idle time with researchers and other stuff like that. So yeah, it's kind of interesting that you mentioned that startup about people really trying to like push a system up. We are trying, as engineers, we are constantly trying to just squeeze more shit out of these servers. We're trying to constantly do more multiplexing for time and for all these other things. Hey, Robodom, how's it going? Robodom's one of my mods. He's always telling you guys about Discord and all that other stuff. But this is how we aggregate over our dimensions, right? So I can do the same thing here. Well, yeah, I think that one's pretty okay, pretty self-explanatory. If you need to practice this one, just go and grab your PromQL like this, and then here's some examples. Preserve the instance at job label dimensions and aggregate the instance and job label dimensions. So now they show you how to sum by or without those things. So if you needed an explanation of this, go to this little cheat sheet that I've been showing you. I'll link the cheat sheet for you guys again. I should probably just pin this cheat sheet because this is so useful for this. This is how you aggregate over series of data, right? And then you can filter by guys, this is one of the best things. If you were getting ready for this test, I would say go spend time with all of this. All this free stuff that somebody's put together. I tell you guys all the time, free is so good, but free and like available for you to use whenever you need is also super useful. Okay. So then there's binary operators, and you should know the addition, subtraction, and multiplication, division, modulo, and power exponentation, right? The only one up here that I think most people probably don't know well is modulo. And does anybody want to explain that, or you guys want me to? That is a remainder function, right? That's a remainder check, right? So modulo is divide by a thing and then show me if there's a remainder. Very useful in like simplifying things down into like I want to count every 6th item, so I just do a modulo and check for 0. So now I know if whatever it is divisible by 6 or divisible by 6. If I can divide it by 6 and there's no remainder out of my modulo, then I know that it's a thing. Otherwise, I know that it's some number and I can use that to count, or there's all kinds of things you can do with modulo. But the point is, you can see if something falls directly on a line. like every 6 hours. Easy to do with modulo. Take the time and divide it by 6 across a 24-hour clock. And if you have no remainder with modulo, it is either 0, 6, 12, 18, or 24, right? Start up, you're redoing your CKA and take the CKS. Nice. I have to decide if I'm going to redo my CKA and my CKAD next year. I think I have until September, so I think I'm about a year away right now from recerting those. Because when did I get those? Yeah, 2022, I believe, is when I did those. So, yeah, let me know how it goes. Let me know how the things have changed, because we're all the way up in like 130 now, right? I think we're in CKA 1.30. Or sorry, for Kubernetes, right? So, yeah, too many things to change. Yeah, one of my favorite things, I know people dislike how CISSP and CCSP just make you, keep your studying up to date. That's fine with me. I'm fine with that. I don't have to go take my CISSP or CCSP again. All I got to do is maintain my study hours, which I literally do study all the time. The clock is a modulus 12. Yeah, or 24. True. That's true, Northern Chimp. That's 100% true. Yep. Yeah, the clock is modulus. Yep. So that's what modulo is. And if you guys want to go spend more time with it, you can, but it's very easily with modulo to see if things fall directly on powers or whatever you want to call it. And then power exponentation, right? If something is you can multiply things and find powers of things, right? Here's the binary operator precedence. This happens first. That's almost always true. Then this happens second. This happens third. These all happen fourth. And an unless happen fifth. And then 6 or happens last. That's the order of precedence for pretty much everything that's binary. All right. This is exponential. That's multiplication, division, modulus, and atan 2. That's plus or minus. That's equal, not equal, less than or equal to, less than, greater than or equal to, and then greater than, in that order as well. And or unless, and then or. There you go. Oh, nice. 2025 is a green card year and have to keep up to date. May help the job transition, maintain some activities on your LinkedIn. Nice, startup. Yeah. We have some things down in the Discord going on that can keep people, I think, kind of entertained. But I'm always looking for more people to come up with stuff that is interesting to people as well. We've had people over the years try to start like CISSP study groups up, but we didn't have a lot of people interested back then. But now, and that was back when we had only like 800 or 900 people. Now we're up to like 2,400. We might be able to squeeze out enough people that want to, because look, CISSP is not for everybody. Not everybody wants to go do that. Not everybody's interested in that kind of cert. Some of you guys know I got that cert simply to argue with my security team. I was arguing with them about so much stupid shit that I got that so that when I sent emails to them, I could put that on my email. You guys think I'm kidding. That's actually why I spent $800 of my own money to take that test. It was $795 when I took it. So anyways, here's a histogram. Remember I talked about buckets of things? Percentage of seniors age 65 and over in each country. And what a histogram is buckets of observable outcomes. They help generate ideas about what is happening with the data. So here's a number of countries, right? And then percentage of seniors age 65 and over in each country. And then here's the percentage. There's 0, 1, and 3. There's 3% is not, let's see, hold on. Percentage of seniors age 65 and over in each country. Yeah, 0, 1, 2, and 3% not there. 4, 5, 6, 7 are there. But the percentage starts to get a lot higher between 11 and about 27 as the percentage of seniors found within X number of countries that are over 65 years old, right? And then we can use this data. We can start to look at this data, and maybe we start to look at this data by time slice and see if it's changing, see if there's a severe drop-off of things. There's all kinds of things that we can do with data here. And histograms help us to prove out what the shape of our data is, so then we can start to figure out from here, we can figure out what our mean is. We can start to figure out from our mean all of our standard deviations, And then from there, we can start to figure out, whatever we want to learn about the data and treatment effects. And some of that stuff starts to go into like economics and stuff. And difference in differences type concepts and that kind of stuff, which we don't really care about that kind of stuff, but you might want to go look it up if that's interesting to you. For us in the data sense world, we just want to make sure that we have standard distributions, and then we start to figure out why there are outliers, that kind of stuff. All right, histograms in Prometheus. There's libraries that support histograms. It must be configured for it to work. The assumption is a histogram has been generated for, so in this, there's an assumption that a histogram has been generated for HTTP request duration seconds. So meaning that the request duration in seconds have been blocked up into different groups. And then you can go and you could do a sum of the rate. And then you could look for if the bucket is less than or equal to less than or equal to 0.03 for the last 5 minutes. And then look at that compared to all the jobs. And it'll show you all the HTTP requests that were under 300 milliseconds in that histogram. Again, that histogram has to be already set up for you to do something like this to it, right? And then quantiles, they're much more complex, but they're a common statistical characteristic. And quantiles are the idea that if I say you're you're within the 50th percentage, I mean that you're in the lower 50th percentage. If I say you're in the 95th percentile, I mean that you're way up at the top of everything, right? That's a standard value for how those mean. So what this might be is you're looking for things that are in the top 95th quantile as far as the time. And then when you do that, you find the ones that are in just that top 5% of things that happened as the longest time. And then you could do whatever you want with them. You can start to figure out if there's some relation between where they're coming from. You might have to go look at that data then from there. But the point is, you can use histogram to determine the quantile of things if you want as well. And that would be useful in some cases. Excuse me. So I did a timestamp one. Timestamps are given in epoch. This is from my system here. We did a timestamp on when the last Go memstats free total was taken. And this is interesting, but that's in epoch time, so good luck reading that. What you do instead, since it's an instant vector immediately queried, what you can do instead is you can do time and then a timestamp equals. So let's do that one real quick. So let's go look at that one real quick. So we can go query the time is some function, and we'll subtract from that the timestamp of Go memstats freeze total, right? And when we do that, freeze total. Whatever. When we do that, we'll see that within the last 3 seconds, I queried this one. And within the last 6 seconds, I queried this one. And the longest time here is this 15 seconds since I last queried that one. So I could tell how fresh, if I want to think of it like that, this data is in relation to right now on my system. So this is right now, time, minus that timestamp in epoch. So time is an epoch, timestamp is an epoch, and it tells me the longest one here was 12 seconds ago. Oh, got a friend calling me. Give me 1 second real quick, guys. I'm going to take a break real quick. I will be right back. All right. Sorry about that, guys. You guys hear me again? See me again? Okay, good. Yeah, sorry. That was one of my buddies calling me. He's trying to offload something. So, all right. Anyways, you guys see how timestamps work? You take time minus timestamp, you get the delta, and then that delta is useful. If you had data that had not been pulled in a long time, it would show up here. So if some node was down or something, that kind of thing, then you would be able to see that it had not been queried in a long time. So there you go. All right, let's keep going. Let's finish this up. I don't know if we'll get through everything here. The wife's coming home shortly. Here is how the I spelled this derivatives, but it's actually Yeah, well, all right. Here's how this kind of works, right? And there's, oh, you know what? Do these guys have it? I hate when they do that, where now it takes a membership. It used to always be free to just read an article. Oh, yeah, maybe you can see some stuff. So they give you some examples here, and you wouldn't see, this would not, like, let's say, trigger if something were slowly increasing, but once it dropped very quickly, it could trigger. So it says, how can you assess if something's bad? Is only a drop or an increase of plus 20 a catastrophe? Like, what causes something to be considered like an alertable offense? And that's really what this is looking for. When things shoot up or down, we can see the value of this. But it's hard to set, right? You need to know why something would actually be a problem in your system. So we don't show them in dashboards, that's true, because it would be weird to see just the metric of it when it happens, right? They show change, but not a steady bad state. So if something stays bad or has been bad for a long time, it only shows the change to get there. Kind of like if you think of like a Manchester encoding type thing, but it's a little bit different topic. But anyways, all right. So let's talk about instrumentation and exporters, client libraries. There's hundreds of them. Instrumentation, exporters, and then structuring and naming your metrics. If you're going to make your own metrics, which is not that hard to do, you need to make sure that you're following the right naming standards for them. So there's all these official ones that are out there. There's third-party client libraries that cover most of the cases you could run into for sharing metrics. And then you could always just use exposition formats and expose web-based metrics. So you can just take whatever's happening inside of your program and just share it up through like a web page, like you've seen in those other things. Yeah, Mint. So derivatives look for spikes up or down. Yep, that's exactly what it looks for. But it's like, but is something good or bad? I don't know. Like going 60 to 0 is probably a pretty bad thing in a car if it happens instantaneously, but 60 to 0 is not that bad if maybe, I don't know, 60 to 0, maybe if you're doing like, can't think of a good example of that, but probably not good in a car, right? Anyway, so look, instrumentation, right? There's different types of services. We've got online serving systems, so humans are expected to do an immediate response, so we want people to look at it. There's offline processing. No one's really waiting for a response. Things are just sitting there. And then there's batch jobs, which are offline processing that's done in batch jobs, but batch jobs are distinguished by the fact that do not run continuously. So scraping is difficult with batch jobs. That's true, because batch jobs only exist while the service is running. Like if any of you have ever like backed up servers from like 12 to 3 a.m., so 12 midnight to 3 a.m., and then your servers stop. Even if they're not all done backing up, they stop after midnight. There's a lot of tools that'll do that for you. That's hard to quantify, but you could say they didn't get through all their work, or they're getting through less work than they used to, and then we need to figure out why, and figure out why we're starting to back up on jobs and not catching up until the weekend and all that kind of stuff. Maybe we need to do more what we call incremental backups. Or maybe we need to do, what's that other type of backup that's very popular? So you got your incremental, and then you've got full, obviously, but then you got incremental, and then what's that other one that's real popular? I haven't looked at backups in a while. Differential, yeah, differential. Yep. So your differentials are nice because you can use them. Yeah. been a while since I've looked. I need to do some more of that stuff again. I haven't looked at my backup stuff in a while. Subsystems exist as part of services. So you've got libraries, but your libraries, you need to track query counts, how many times the library is used, errors, latency if it's calling some outside resource. These are the types of things you want to look at, right? Internal errors, latency, general statistics. Those are all things that you can feed out as when you instrument everything. Those are the things that you want to look at. Logging, as a general rule, I like this. Every line of logging code should increment a counter somewhere. I had never heard that before I was studying for this, but I really like that. I think I told Salty that too, and he's like, oh, that's good. So if you're going to log to something, that should increment a counter. And I had never thought of that before this, but that's pretty good. Every failure should increment a counter. So thread pools track queries, numbers of threads in use, and numbers of threads active. So that's useful. Caches, you should track queries, hits and misses, and overall latency. Caching is hard, right? Caching, if you've ever done any caching over the web, or like if you've ever done caching of systems with like any of the content distribution networks in the cloud, caching can be very difficult. But it can be made less difficult if we track the queries to it. The hits, meaning we caught something that was still here. Query hit is good. You don't have to go as far. Misses are we close something out and have to go re-query it. And then overall latency of queries, right? Do incremental every 15 minutes. Differential nightly, except on Sunday where you do full. Yep. That's a good plan for that. Collectors export gauge for how long the collection took in seconds, so you can collect just how long collections took, right? So your instrumentation is really based on, are humans looking at it? Is it just offline and people are going to look at it maybe in the morning or at the end of the month? And are we looking at like batch jobs and trying to figure out how healthy those things were since they didn't exist all the time? We don't really have like a baseline all the time for these. We only have like when they existed. But we can still turn that into a baseline over time as we're gathering our data. Exporters, there's literally hundreds of exporters. There's default ports that are known and they're maintained here. Here's the primary ones, 9090, 9091 for the push gateway, and then your alert manager, and then alert manager clustering. So you could have all this stuff on one server. And then here's the exporter starting at 9100, node exporter, and then just a whole bunch of them. Just keep going. Remember I told you guys there's a lot of them. Yeah, and a hard copy in a different building, sure. What is it? It used to be 432, but I think the rule is 3221 now or something. 3 different copies on 2 different types of media in 2 locations and 1 offline or something like that. There's something. One is air gapped rather, or offline in some way. Look at all these. There's all kinds of them. And you can download any one of these that was interesting to you. Maybe you're using Lustre. You want to gather Lustre data out of a system. Here you go. Look at all that. So many things. All right. So come back over here. Best practice should be followed when writing exporters specifically around metric names, formats, and labels. And then this one, I need to practice this. But the black box, you can go run your own black box exporter, and then you can then go and look at what's being exported out of there. And then they give you some ways to go query the metrics out of that black box exporter if you wanted to. So it looks like when I do a query, I can just look for the individual metrics if I wanted to. And those are the labels there. So it looks like I can query those as I go. So that's pretty straightforward, I guess. And then you can configure modules inside of your black box if you have one. That seems pretty straightforward, I think. Probably won't be using that much, but it's interesting. All right, structure and naming. Make sure that you have, there's a data model for valid characters. That's what we talked about way earlier. And then single word application prefix, typically namespace like Prometheus or HTTP. So you saw that my system had Prometheus all throughout it. Must have a single digit unit. Don't mix milliseconds, seconds, and megabytes together. Should use a base unit. and there's a, not milliseconds, megabytes, or kilometers. It should be seconds, bytes, or meters. And there's actually a list of best practices for those naming units. The suffix should be the unit of measure. So is it in seconds? What is it? Should represent the logical thing being measured across all labeled definitions. Keep the same measurement the whole time. Don't do megs over here and gigs over here. Don't do that within the same type of exporter, right? Instrumentation, they've got some best practices, and then writing your own exporters, they've got some best practices. So that's up there. That's all. By the way, this is all up in Discord. So if any of you guys want this presentation, it's up here in Discord under our presentations. I haven't mentioned it in a while, so I'll mention it. We got a whole bunch of events coming up. We've got Salty Catfish is doing the Code Cove on Sundays. We have a engineer coming to talk next week, and then I'm starting the week after that on the Linux Systems Administration course, right? So there's things like that for you guys to mess with. All right, so let's go look at alerting and dashboarding. Again, this is not that much, but you still don't want to drop any points there. But why do we alert? How do we use Alert Manager if we're going to use Alert Manager? How do you configure the alerting rules? And then what are the dashboard basics, right? So their Prometheus guidelines to dashboards have no more than 5 graphs on a console, no more than 5 plot lines on any one graph. You can get away with more if it's a stacked area graph and if it's like kind of aggregated. When using the provided console template examples, avoid more than 20 to 30 entries in the right-hand side table. I've never used a console template example, so I wouldn't know what that is. But if you find yourself exceeding or violating these, you should think about breaking down your subsystems and graphing aggregated data instead of broken down data. So what that's saying is if you want to show like 30 graphs and you're like, maybe I need to group some of these up and say, instead of show everything, I show all my good stuff, all my errors, any of my time outliers. Maybe that's what's useful for people to see. I'm a big fan of breaking down console dashboards based on purpose. Who are we trying to show it to? A lot of times, like I'm an internal, like I'm the systems engineer running the system internally. I want to see a certain set of things, and then my management team wants to see totally different stuff than I want to see. But there's kind of a hybrid in between there. There's like our security operations team, like a SOC or a NOC, network operations team. They might want to see some of the same types of things that I do, but they might also want to see like an overall health, almost like a management might. So they might see like almost like a hybrid of some of them. One of the nice things about if you're using Grafana, everything is just copy and paste and move. So you can take a whole one of these. If you're looking on, where is it at here? If you're looking at one of these and you're like, oh, that one right there is really useful. Look at that server memory. You can just grab this thing and you can copy it. Oops, I didn't mean to duplicate that. Hold on. Don't save. Yeah, so it doesn't save. I can grab that. I can copy that. Boom. And then I can go take that to another page, right? Even like, well, Ranger Check's on a different server, so I can't copy it to there. But let's say I went to up-down nodes, right? And I just wanted to see which nodes were up, and I can right-click, and I should just be able to paste that in here. I don't know, maybe not. But I should. Anyways, the point is, I should be able to copy and paste things in between these different nodes. Where do I paste that? I forget. But the point is, you can do it. Share dashboard. Also, you can share things out. But anyways, yeah, Grafana has a whole bunch of functionality that makes it like super useful. Yeah, Robdom, I think the Linux course should be good for everybody. I was building it out earlier. I don't know if you were around earlier, but I was building stuff out with it. So, all right, alerting rules. You go into your system and you define alert conditions. And in this case, if an instance is down for 5 minutes, then you can send a summary alert. In this case, out to like a, where are they sending it to? All right, so here's the alert definitions here. Here's the rules. And then we can alert to different places, right? These are just the alert definitions. This is not where we're actually setting up the alert. So let's go look at where we set the alert up. So that's the basic stuff. And then there's some templating that you can have. And then sending the alert notification, you got to go look at the alert manager. Where's that at? So here's your global things, like where you're going to send things out to. Ops Genie. We use Ops Genie sometimes with this. And you can send it to different things that you have, wherever the Ops Journey or Ops Genie is. All right, so there's a bunch of stuff there for you guys to mess with. I definitely need to understand my alerting better, but I think I understand this part of it well. You can have your labels for severity, and then it can be page or it can be email. You can also have different times of day where certain alerts don't go out, right? There's a bunch of stuff like that that you can query. Then there's a summary and a description, and you can set those up based on what you want to see, or a description should have just the information, like just the facts, ma'am, right? That kind of thing. All right. Here's the things. Yeah, we're routing inhibition settings, meaning if multiple things are alerting at the same time, they can be inhibited as long as they're together. And then label matches, alerts to route, silencers, and inhibition rules. So that's what the label matchers are. Then there's also a linter. Linter is anytime you want to make sure your shit's not broken before you feed a new config into something, right? And it's compatible with UTF-8 strict mode, meaning you can use that linter against the file, and then you can read and make sure that this is exactly like what you want. So that's useful. Make sure your config will work. All right. Alerting must be done in camel case. That was a decision that was made before any of us. Oh, wife's here. Hold on a second, guys. Nice. Now I got snacks, guys.
Okay, I love you.
All right, I'll see you later. Did you give me 3 of these? Oh, nice. Dude, wife got me all kinds of food, guys. I didn't want that much food. But I'll take it. So, here's what we got, guys. Yeah, happy Scoot, happy life. Yeah, she brought me a drink, too. Oh, wow. My wife's taking care of me. So, I'll show you guys what I got here. Here's my... If I was a pirate, this would be my pirate booty right here. This is salsa from her friend. Her salsa is really good. And she gave me a plate and a spoon for that. And then I got these little guys, which are little quesadillas from Pollo Loco or something. So now I can eat the salsa with that. So here's my options. I can keep talking to you guys and munch on this off camera. Here, I'll put Ranger up so you guys can see Ranger. Where's Ranger at? Ranger's not on there. Ranger's over here somewhere. Ranger's off camera. Nobody knows where Ranger is. All right. Critical warning and info. Some things are routed immediately. Some things are routed eventually. And you can decide what eventually means. All right. Now I gotta decide if I want to put some of the salsa on this little chicken taco she gave me. I think the answer to that's clearly yes, right? Isn't that clearly yes? Let's see. Hope the salsa is as good as normal. Her friend makes pretty good salsa. Because Pollo Loco's okay, but with this salsa, it's pretty good. So I'm gonna give that a chance. Yeah, the wife was hooking me up. This is the main reason we keep wives around. No, I'm just kidding. Don't tell her I said that. She probably heard me from the other room. All right, I was saying summary and description. Those are mandatory. Summary and description. And they tend to be readable version of the alert name, and then detailed description of a single alert with the most important information templated in. So we're templating in what the labels in the instance are, what the labels in this case is just the instance, and then what the current value is. So that's very valuable there. All right, let's see how this is with the salsas. Pretty good, guys. But can I make one complaint? I do not like cilantro very much. I know everybody else loves it. I don't like it that much. Thankfully, this friend does not put cilantro in her salsa. It's only in the one taco I got. So the cheese quesadillas won't have it, and neither will the salsa, so that's good. That makes me happier. Can I tell you, I don't think it tastes like soap. I think it tastes like something out of the garden. I think it tastes like the dirt. So, I must be that 15%. I think it just tastes like it came right off the ground. Which is funny, because I like leafy vegetables otherwise. But cilantro is not one of the things I like. Alright, let's keep going. Digging deeper. There's some docs here, and the docs are around how we set up the alerting, what's some philosophy of alerting. This goes back to that docs.google stuff, and then the alerting, you know, that SRE type stuff that we were talking about. What do we want to show people? When do we want to call them out? When does something break a service level agreement in such a way that it warrants waking people up? Some organizations are going to classify that by, are we losing money? Like I used to work at GoDaddy. I ran their network operations center many, many moons ago, like in 2006. I ran all their network operations. And one of the things about that is I would see every 5 minutes how much money we had made in the last 5 minutes. There was a little metric that showed up. And if that number ever dropped to 0, I was supposed to immediately start calling people. And that's like a thing they wanted to track. They wanted the network operation, they wanted eyes on how much money they were making every 5 minutes across the organization. Oh, some good salsa. All right. So here's additional training and topics. So when I worked there, Bob Parsons had just moved to Phoenix. We were out in Scottsdale. They used to have a facility on 82nd Street and Raintree Road. And while I worked there, so to get out there, you had to come around the 101, which is a road out here in Phoenix. And he laid his bike down twice coming out to the facility on the 101 in 2006. And he chose to no longer drive his bike in, and he chose to not like Arizona drivers very much. I do remember I was sitting there one time and he called me. So Bob Parsons called me out of the blue. I said, I just wanted to see how the network was going. Network operations, right? I was network operations center for the whole company. It was probably 1 a.m. And I was like, sir, not that you can't call me whenever you want, but isn't it a little late? And he goes, no. I took the plane out and I've been hanging out in Hawaii at the house the last few days. I'll be back in town. And I was like, oh, okay, cool. He was pretty down to earth when I talked to him. I only ever had him on the phone a couple times. But yeah, he was pretty alright. All business, you know, which is fair. But I had a buddy that worked there who was employee number 80. And he went on to run their data centers, and then he ran Expedia as their chief information officer. So then he came back to Arizona and ran our chief information officer for the state of Arizona for a while. And last I checked, that guy's over at Amazon right now, AWS. Mm-hmm. Yeah. Yeah, he and I, we went to college together. And then, funny enough, I introduced him at a DeVry commencement ceremony for graduates one time. And then he's been kind of on the talking circuit ever since. That's kind of funny. So sorry you guys got to listen to me munch right now, but all of these things here are similar to what I showed at the beginning, where these are all things that you can go spend more time and read about or absorb this more. The top one here is that same one that has the cool little cheat sheet, and then the cheat sheet lets you go and look in the actual Prometheus instance. They have a basic little training to get ready for PCA certification. They've got a basic one that's free, and then they've got a paid for one. But you know, I'm a big fan of just doing the free one. Right. So you do that, you get ready. There's some basic question banks on Udemy for $10. You know, decent little stuff to just get you a little more exposed to some of this stuff, the types of questions that might pop up. Get you feeling comfortable with trying to get to 45 of your questions correct, obviously, you know, because that's valuable. Oh, don't want to throw my trash in there. Whisper, it is. Here's the exam format right here. Way at the top. Been through all this. Look how much we got through today. This is the exam format, right? Oh, excuse me. Right there. Online, 60 questions. You need 45 right to pass, which is approximately, well, you get greater than 75%. You get a free retake, which I think is doable. Make sure that you're ready. Yeah, Cuddlingus, if you were at 0, that was everything. So, yeah, maybe that's a lot. But if you play with Prometheus for a little bit and then you watch this, or you come in here and kind of look at this later, you might find that, you know, it's not unwieldy. It's not too much if you're kind of doing this already. And then questions, drop them in Discord. But mainly, you know, that training stuff right there, I think is probably pretty valuable to go spend some time in there. And sorry I'm not talking much, guys. I'm still munching on these things. So, wife brought me some food, so I'm munching on it. Yeah, wife brought me some food. How was your thing, Robodom? You were out working on learning sheet metal, sheetrock? Sheet metal and sheetrock? All right, give me a second here. My munching should go to a minimal here soon. Put all this trash away. All right, all right. Mint, you had Prometheus, Grafana, and Alert Manager stood up. Raspberry Pi, a couple of out-of-box dashboards and exporters. Nice to understand PromQL. Yeah. And then Mint, if you've never done this, this is kind of cool. So let's say you go to your Prometheus and you're like, yeah, I do want to know this stuff about maybe my home. Here, let me turn myself back on here. And you say, yeah, I do want to know this about my system. I do want to know something. Let's go back over here. Ranger Cam, ProLUG, up, down. And let's say yeah, Flux never really got super popular, did it? I learned Flux enough, but I really like this. So let's say I go here and I want to know node. Let's just say ARP entries. Oh gosh, that was no good. I want to know all my ARP entries by device. I can see how many ARP entries maybe exist for my nodes here, right? And this is cool. But then maybe I say over the last 5 minutes, and then I can see that they've kept maybe a steady state. But let's say that I just want to do that. That's fine. Node ARP entries. That's going to give me something useful. I come over here, and I'm just going to add in a new widget. Should be able to just say, where's it at? Hold on, it's right there. Sometimes things are a hassle on here when they're not easily seen. Let's just add a panel. And then we'll just say a new panel. We don't really care. And in here, I'm going to change it over to Prometheus because I know we've got Prometheus. And I want to just set in a query, and I can just run the query. And then I can just examine this data and go, okay. I'm seeing all of this stuff. Maybe that panel looks good to me. So I say, okay, ARP entries. But maybe ARP doesn't matter. Maybe I say, I don't know, system health, network or something. Because now I can figure out, based on this, what I consider to be a healthy system. Right. Oh, nice. Quartz. What were you going for? Were you going for a new roll quartz? I might have missed it. I'm looking. I know something was happening, but I don't remember what. Yeah, let us know what's going on there. And then maybe I just apply this, and then I look and I go, okay, that's okay, but maybe that only matters in the context of having greater than something, like some number of ARP entries, because why would a node not have many ARP entries? Well, maybe it doesn't talk to other nodes, maybe it's not actually healthy on the network, and then I start to use that, whatever I'm gathering here, I can just start figuring out things that I might want to see. So let's go here, node, CPU seconds total, and then gauge, right, disk device mapper, and all these different things here for me to look at. What's my file system free bytes for maybe whatever. And then now this is only going to mostly be useful for me if the mount point is here. So then maybe I say I only care if the mount point is equal to root, because that's the only mount point that matters maybe for me. And then I go, well, that's cool, but that's like a big number, and I need to have it as like a percentage. So then maybe I go do it based off of that same thing, but it's percentage. This is how many free bytes it has. Oh, so that's free. So yeah, I could just use that, and then I could drive that down with like divided by, I don't know, something like that. And that would be how many gigs. Yeah. think there's one more for gigs. Yeah. That's how much space is left on any of those. And if I wanted to go check, I go to my 180 box, right? Let's go check. Let's go make sure my counting and my numbers are good. So I go to I don't even know what node this is. Oh, that's my Loki box. And he's got 81 gigs available on his home. Which is not quite what we see there, but that's probably the difference in bytes and yeah, that's probably within the margin of error. Let's see if there's a free. We can only see bytes here, but we could figure that out against the whole. Yeah, Quartz, there was an update to the book. I pushed it out today finally. It was a month later than I hoped for it to be. But we had one of our guys put together some pretty cool little artwork. So this is what it looks like now for people that have never seen the book. Now it's got this little guy on it. So ProLUG, the ProLUG Big Book of Labs, right? And you get in there, and we added TMUX. We added all of this down here. Our syslog, operate fire system stig scan, Firefox stig scan. So a whole bunch of new things in there for you to go and look at. So yeah. So if you got, so for people that have, anybody that's ever bought the book, you get all the updates. That's one of the cool things about LeanPub is you could just be like, oh, I'm thinking of writing a book. And then anybody that wanted to and was like, hey, I know that guy's going to make a good book, they could buy the book. But yeah, if you have the book already, you will get all the updates I ever put out for it. That's one of my favorite things about LeanPub. And technically today I put it to 100%. I had it set at like 98%, but I'm calling the book done. And then I may add labs in the future, but for the most part, we're calling that done. And I might put one together that's just like system administration, which is just that's gonna be much more theoretical, but it's gonna be a lot of my kind of thoughts and what I think you should do around systems administration, how you should manage systems and stuff. So, look, we won't save this page. Look, yep, just leave, don't save it. All right, we got all the way to the end. All these things are there for you guys to go spend time with and get hands-on. I really like our server build lab. If you guys have never done Linux telemetry and you want to do Prometheus, that's what this 103 lab is. I think it's pretty good. And if you guys have questions about that, just drop them in Discord for me. So let's save that. Make sure that one's all saved. That one also, I dropped that up in Discord earlier today, so you guys have that Prometheus. That's everything I got for ProLUG Prometheus Certified Associate. That'll get you as close to it as I can be. I haven't taken the test yet, so I'll know later. Look at all these people showing up. And the bot's talking trash, because that's what the bot does, talks trash to new people. There's also beginner start here. All kinds of useful stuff for you guys to go spend your time in down here for data certs and that kind of stuff. Things that you might find useful. All right. So, what else do we have to do today then? I did all my Ansible. I got that all working. I could keep working on the other system. I don't really have anything else. Tomorrow we're going to do labs, right? That's what we do on Sunday mornings is labs. We just work through labs. We get stuff going there so that we all hands-on, right? Just hands-on labs up and down the board. We'll probably start tomorrow with. Let me ask this here. I'll do a little thing. I haven't done one of these in a while. I'll do a survey. Where's the survey at? Or a poll. And the poll is over on the Twitch side, and it'll be what labs tomorrow. We'll say Linux, Ansible. So we'll say Linux basics. Like start over on Linux. Linux services, or Linux security. Or you know what? I'll give one more. Kubernetes. We can do Kubernetes all day tomorrow too. There you go. Boom. You guys can participate in that poll if you want. You got 10 minutes. I can sit here and watch the thing. All right. There's Ranger back on his bed. I do have to finish working in... I got more lab stuff to do, I guess. So... let's do something here. History, more. And let's... that's not a very good history. Doesn't really have any of the stuff. Let's do wwctl node. Whoops, node. And we can add a new node to Werewolf. But before let's see if we can. I want to modify some things about our nodes and see if we can update them. So let's do that real quick. So it's a lab environment, so I can take downtime, right? Normally, if I was getting ready to take downtime on a system, I would let people know, but since it's a lab, I don't care. And let's go to one of our Rocky boxes and let's turn off Rocky. So Rocky's going to be down. And then what I want to do with Rocky, once he's down, is I'm going to take all of his storage here, right? Once his node's down, and I'm going to see if I can move his storage over to this new set of disks that I have. So I have this back-end super fast set of disks for this node. I put them in the other day, and they are, yeah, they're this lab SSD. So what we'll do is I'm going to move him over there. And let's see, he's down. Okay. So let's see if we can move this to this other storage. All right. Let's see if we can move multiple. We can. So let's see if we can look at the properties of this disk now that he's down. And can we move, I don't really want to move that down because I don't want to break anything here. But let's see if we can move all of his stuff, move all of his disks over to lab SSD with no problem. Let's just try that real quick. So it says that he's doing some moving, that's fine. And then my Rocky template, I'm going to do that same thing. That's on the lab storage, and I'm going to see if I can move his disk, over to lab SSD as well. So I'm going to move everything over. All right. By the way, you guys are also, it looks like you're voting. SK, you moved your display name again. Oh, all right. We'll call you Ops to Dev. That's a pretty good name. Quartz One, are you asking me that? I have a couple of, they're pretty beefy servers. They are, one's got 128 gigs of RAM in it, as does the other one. And then, yeah, he's got 128 gigs, and this guy's only got 32. So he's a little smaller box than the other, but he's one. So this is a Dell 610. I think these are 620 and 710s. I forget. They're Dell. They're old Dell boxes. They're out of warranty. They're just old servers that friends have given me or I've bought out there online type stuff. So Quartz, hopefully that answers your question. That's what I'm using. Just home stuff, you know. Home grade servers, nothing super special. So they're still on lab storage, but I expect them to be moving over to this other storage called lab SSD. So lab storage to lab SSD. And then once that goes, I'm going to boot this box up and watch it come up. right? So we'll let that run for a little bit. We also should be able to go see down here in notifications if there's any problems. So it looks like it's moving the virtual disk. It's not having any problems, but it is doing it kind of slowly. That's fine. That's fair. Once I get them all moved over there, what I'm going to do, yeah, Quartz, I mean, anymore nowadays, I'm used to, like, I'm working on boxes that have 2 terabytes of RAM in them, you know, like the big like, clients for my, actually, let me go look at one of the boxes real quick. Hold on. Let me go pull this over here because I can't show this to you guys, right? This is work stuff. Let's see what this one is. Let's go SH2. Let me check this one real quick. Oh, only 64 processors? That's less than I would have thought. And this guy's only got 516 gigs of RAM, so he's a little smaller. But that's also a GPU node. So, alright. So that's the kind of thing. So we were doing Prometheus earlier, ops to dev. That's what we were working on. Thanks for the follow, Sahan Doxy. Hopefully this stuff's useful to you. Where is... Oh, we're still doing labs. You guys can vote on what labs we work on tomorrow. We can do Linux basics. We can do Ansible. Linux services, which will be more of like starting and installing things. And then that. Actually, what I should do is I'll go change our title to... I'll go change that to working on lab for the ProLUG. So that's all we're doing now. We're just messing around, guys. We're not working super hard. Hopefully that'll let me change this on the fly for the YouTube side. I've never tried to do that before. I don't know if that splits it to a new video or what, but okay. Yeah, ops to dev. We might do that tomorrow. If you vote, we might do some Prometheus monitoring tomorrow. Who knows? What's going on here? This thing is definitely taking its time, but that's fine. We'll let that thing take its time, and then we'll say node. Let's add. Well, we're gonna wait to add nodes. Once we get all this stuff moved the way that I want. So that's moving, and the Rocky template. Ah, this is already moved over to there, so that's good. And while we're waiting on that, I'm gonna check something else. I'm gonna rename this to ProLUG lab here, and then we're gonna move to root Ansible CD to playbooks, CD to werewolf, and then what did we put in here? So we've got a lab environment.yaml, and that's got those basic nodes, and then we've got our lab deployer, which was deploying them here for that. Okay, I think this should do. Might do what we want. Let's see. Let's finish this up. We'll let this move. It's moving the last disk over. See, the other ones are on SSD. And those are fast SSD and a RAID 6. What do I do? RAID 6, yeah. Ops to dev. I don't care what people vote for, but Linux security is a good one. We did those last Sunday, though, so that it would be similar to the stuff we already did. But I can always add more color to it. Like, I can always add more commentary around whatever we're doing. And we can always branch off into other things as we kind of go. So, All right, we're at the end of the vote. It looks like Linux Basics is going to win. We're just going to do basic stuff tomorrow. That's good. That'll hopefully keep people involved and motivated, which is always useful. Let's see if this thing will finish up here while we're watching it. Yeah, ops to dev. I saw you say that earlier. Yeah, I saw that you're SK. Yeah, you're. We don't know what to call you, but as long as we know, I guess generally, it looks like Linux Basics won, so that's good. We'll do Linux Basics stuff tomorrow. That's good. Look, I don't think you can go wrong with the basics. Just hitting buttons and building stuff, and I think that's valuable. So, yeah, that's what won. So that's what we're doing tomorrow. I'll put that up in the Discord. We're doing Linux Basics starting at whenever I get on to do it. Let me go check. I might have some work stuff to do. Let me see if anybody messaged me. Did we get? I didn't get any work updates. We had more work to do today, but I don't think anybody messaged me. All right. Yeah, nobody messaged me. I guess we're hanging out here until the wife comes back. All right, all of our infrastructure's up. Rocky has moved over to SSD. So let's do this real quick. Let's boot that node up and make sure that he comes up in a healthy fashion. So we're going to start him. Once we start him, we're going to go to his console, and we're going to watch how fast he pulls down his information from here. And by the way, we could tail -f var log werewolf. Oh, wrong node. Var log. So now watch. We can watch him grab his information. We can actually see him pulling down the files in real time over here in the log. He's going and grabbing Rocky 9 lab, and he's doing all the things that he needs to. So boom, there we go. Yeah, see, he's pulling all of his stuff. What we should see in an SSD environment is a marked improvement in the speed of this system. That's what I would expect. In fact, we can go and we can test the speed between these two devices now, between these two different systems if we wanted to, just for fun. We'd have to we'd have to probably build a disk and just mount it real quick. We could do that. Mint, that's fine. I'm okay with any of that stuff. All right, so it's coming up. This is the overlay for the system. I can see it calling all the things that it needs. It's going to set up the system and start to boot. And then as soon as it boots over, we should be able to come over here and SSH into that box. There it is, SSH Rocky 1. And we're immediately in the box. Uptime, not even a minute, so that system's back up. So, df-h, and we see all the same basic stuff that we did. Although, funny enough, this node is back to its smaller tempfs because we only changed those, remember, in their etcfs tab on the local boxes. So the other nodes are at 3, but this one's still only at 2. So that's something that we've got to probably modify as well, and we'll do that over in the system overlay. But now that we've got that done, and now that we've got this one here over to that, let's see if we can't provision what we were going to do from earlier. All right, so here, let's vi our lab environment.yaml, and we're going to leave those. I think that all those ones that are there will just keep getting built, and so this is a simple YAML definition of all the nodes that we were deploying with Ansible. That's what this is right here, in case anybody's wondering. I don't remember if we actually used this when we set this up, but Here's the thing: the first 5 will they won't work because they're already there. But will the 6th one deploy? That's the question here. So let's do Ansible playbook, lab deployer, dash ask vault, asphalt pass. I always forget this one. I think I did that wrong. Ask pass vault, ask vault pass. I always get that one mixed up. Oh, there it is. We'll see it fail 5 times. Yeah, I actually have Rocky running in here on a RAM disk. Oh god, those stupid cows are back. I didn't turn off CalSig. Those first 5 nodes are already there. See how they're already built? But the 6th node needs to be built from this templater. And it should be built off of this, and then there should be a 6th Rocky node right here. If the 6th one builds, which it should build right here as the next Rocky. There he is. Now he failed, but why did he fail? Interface target less. That's fine. That's fine. I'm not super worried about that part of it. We can fix that part for the networks. The interface target VM is 1 is less than 4. And why is that, by the way? I think it's because I only have the one network. I could just make the other ones bullshit, but it doesn't really matter. What are the other ones, by the way? Yeah, they only have 1 as well. All right, so let's come back over here now, and let's do wwctl node. Exit. wwctl node, and then we can add Rocky 6, right? And then if we do a wwctl node list, oops, then we should see all of them. And if we boot this Rocky right here, and he's configured properly because the base template was built properly, he should boot up and go get, he should go B6. When he comes up here, he should start up and he should grab Rocky 6 right here. We should see that here in a second. When he boots up, he should see that he is the next node. Let's see. That is not good. No. He shouldn't be Rocky 3. He should be Rocky 6. Three is definitely already provisioned, so he should not be getting 3. Let's see what happens anyways. I'm curious what happens. So he's booting his Rocky 3, which is not what he should be doing. That's not what he should have done. But let's see. Let's see what he pops up as anyways, just for fun. All right. Yeah, it does Pixie boot every time, Mint. Yep. In fact, in the clusters that I'm working with professionally, we just Pixie boot the nodes. They come up off the image every time. They have local storage, but we don't care about it, and they do everything off of their high-speed network. Yep. Yeah, we get really, really fast speeds off it. It's ridiculously fast. Why is this so? I got to look at a few things here. One, what's the MAC that this got? So for the internal, it grabbed some bullshit MAC, which we didn't want. How did these ones do? They all got bullshit Macs too. That's not what we want. That's not what we wanted. All right, let's turn this guy off. So we'll shut him down. We're gonna get rid of those other networks because we don't want them. Can't get rid of him until he's off, so that'll take a second. Remove. Yep, permanent's fine. We don't want to remove lab internal though. That one's one that needed. And actually, I think I have to remove these because I'm pretty sure this happened last time. Is it went out and grabbed a MAC address? And by the way, that's probably part of the reason. Let's restart this one. I'm pretty sure that's what happened. Was it came up and it went in and registered as that old node again. So let's turn this off. Let's let this start over. And now it's not going to have that external. One of those other interfaces was going out and grabbing a DHCP. I didn't even look at it here, but it was an external DHCP. This is now going to be internal, and it should grab. He's still trying to grab Rocky 3. That's not right. He should be grabbing Rocky 6. So, CF. Nope. So that's not what we want for him. We don't want him on 3. We want him on 6. So node list Rocky 6 dash A grep dash I Mac. Just grab everything. See, his Mac is not hard set. Let's go look at 3 though. But his hardware address 5, that's... Yeah, that's not right. So we got dropped into a CH root, so we're in a busted shell. Busted system wouldn't come up. This system thinks it's 53 like it should. But why does 6 think? That's a different kernel, that's a different system completely. Let's see what he comes up with, because he's supposed to be the Rocky node. I'm not sure exactly what's going on. Hey, Practical, how's it going, man? I know you were on earlier working on stuff. I didn't actually get in there today. I should have grabbed my freaking experience. Damn it, I missed it. So if any of you don't know, Practical, he streams some good stuff around, mostly him doing push-ups. He also got me motivated to get a green screen, so that's why I got a little green screen behind me now instead of you just seeing my office. Hold on, we're trying to see what this node's booting to. Now he's booting to Rocky 4. What the hell? Alright, so here's the problem. We're in a stateless environment, and our nodes have always booted 1, 2, 3, 4, 5. I added a 6th node, and now they're booting to whatever the hell they want. Like, this node, which is Rocky 3... is booting as Rocky 4. So if you're going to have a stateless environment doing clean stateful or stateless things, meaning your nodes come down and they come up correctly, they all have to come up with the right damn name. So like now 3 is going to think he's 4, but he's not going to come up properly because 4 is up. So this is a problem. I got to figure out why my nodes are doing dumb bullshit. So he has a default MAC of 6A, and you don't need to remember all of it, but 2711, and then 2711 is not. So this 7B, 6B, we're in Rocky 4. We're looking at Rocky 4, but that's what Rocky 3's MAC address is. 7B, 6B. So damn it. So we got problems. So what's happening is, oh yeah, you walked in NPC. I did a bunch of stuff on Prometheus earlier, which is monitoring, and then I've been working on putting together a like 16-week primer for Linux for people. That's kind of what I'm doing. Yeah, just in time to watch me go crazy, lose my damn mind. Why the hell are my nodes not keeping their state over here? So when we do just a regular node list, right, we see the nodes, we see the profile, we see the default network. We should be able to see, like, if we do like one should see he's CCCA, and then if we go look at Rocky 1, he should be on his networking CCCA. And if I reboot him, that should stay the same. So why is that not? Oh, hold on. Let's go for all of our Rocky nodes. Let's just do node list all and look for grep-IE Rocky, and then let's look for discover. Hold on. I think we might have. That's weird. That's not what I wanted. Let's just do ID. That found everything. So wait, hold on. False. I want discoverable to be false because then it doesn't change. But Rocky 5. What the fuck? This is not what we wanted. And it's weird because I know I've rebooted these and I know this hasn't been a problem before. But it just started today when we added the 6th. Once we added the 6th node in, and he thought he was 3 for some reason. I don't know why the system did that. And 3 thinks he's... Well, he's dead. 4 still thinks he's 4, I hope. Yeah, he's 4. 5 is still 5. Let's look at the hardware address of each. So why does a node think? So Rocky 1 thinks he's CCCA, that's correct. Rocky 2 thinks that he's 72DB. So Rocky 2 is in his MAC 72DB, right? No, actually 6 is a clone of the template. So the template didn't have any of those. And his MAC should have been switched anyways. 1A63, it should have been generated. That is, I mean, that's a good thought. But no, Rocky 3 has his own network here. 7B, 6B. And 7B, 6B has now moved to Rocky 4. So 3 is booting thinking he's 4 and breaking. There's no rhyme or reason to this for me. So what I think I'm gonna do is turn these all to discoverable false, right? I'm gonna, oh God, I hate doing this. I'm gonna hard set them to the MAC addresses that they've got. So like 1 is gonna stay here. He's not discoverable, and that's his address. He should be able to boot right now. Like I should be able to reboot him, and he should come back up as the right node for Rocky 1. So let's verify that that's true. Let's verify that this isn't changing. because this for sure changed here recently. This one definitely just changed. And I don't know, maybe discoverable had been set to true on those before, and then now it's false once it locked. That's the only thing that I think that's plausible here. Is discoverable was set to true, and when those booted, they found that other thing. Let's see, this better be Rocky 1, or we've got problems. No, it's right. That's right there. So this should be Rocky 1. Okay. So let's set, let's fix these real quick then. So wwctl node Rocky 5. Set this default equal to, and then we got to go find his Mac. So Rocky 5 is hard coded to this Mac right here. I don't think I'm gonna be able to copy it either. Yeah, is it gonna? Oh, it will let me copy it. Thank God. So that's gonna be hard code. Whoops. And Rocky 5. And then it's going to ask, do I want to modify the one node? And then I do my wwctl nodes list Rocky 5-A. And it should show me that he's got that hard set. Yep. E668. 668. Good. Now, if that's true, and see, his discoverable is true, so we got to set his discoverable to false. He's going to be our test right here. Yes. We're going to rebuild his overlay. Overlay build for Rocky 5. Oh, Rocky 5. So an overlay build means all of the packages and all the things about that node that are not based on the container, they're things that are added later, get rebuilt. So let's sh Rocky 5 and reboot. Oh, sh Rocky 5. And then reboot. There you go. Boom. All right. Yeah, so Mint, everything inside of Rocky can be customized within these nodes. I'm doing some really basic stuff with it, but we want to watch this box boot up and make sure that he's coming up as Rocky 5. Then we'll go make sure that same thing in there. Mr. Couture, I'm not doing Docker in here, but I do have Docker in my environment. I do have Kubernetes running in my environment, specifically K3s. I was running K8s in a full Kubernetes stack a while back. Wait, hold on, I missed it. Yeah, he's Rocky 5 still. See how he's Rocky 5? So that's good. Make sure he boots up and everything's good. And then we'll just go, we're going to set him and we're going to make sure discoverable's false. Because I think discoverable was set to true on those somehow. So we're going to clean it up. We're going to hard set them. And then we'll leave the new nodes that I'm building in discoverable state. And then we'll let them come up. And I don't know. I mean, I guess I can go set them. I really don't want to build everything manually like that because that's the exact purpose that we're not supposed to do. That's the exact reason not to use Werewolf. Werewolf is supposed to manage all that for us. Let's watch this boot up. Mr. Couture, do you want to know how to go learn Kubernetes if you want to learn Kubernetes? There's some pretty good free resources out there I could show you. That'll get you going pretty well. Here. Go to, there's Ranger, there's my dog. He's downstairs. Killer Coda. Best, oh, you're full right now. All right. Well, this is the best free resource on the web right here. Hands down. I don't think there's anything close. Killer Coda will walk you through. Look, everything here is not even my stuff. This is all other people's stuff. Well, I take it back. These two are me right here. HashiCorp and Ansible. But all these other ones are other people doing cool stuff. If you want my stuff, it's Tanis right here. And there's like a lab link if anybody wants it. And here's the 60-something labs. I think we got about 60 between me and the other guys. We got some other guys, Fisherman, if you want his stuff. We do his labs. He's got some pretty good labs out there as well. Oh, let me monitor my stuff real quick. Hold on. Rocky 5's back up. All right, he's back. He's back to where he was. All right. So that's all what we need there. Yeah, Mr. Couture, that's fine. Yeah, if you're busy with other stuff, you know, I can't make you do anything. But if you were like, hey, I want to be a DevOps guy or an SRE guy, but I don't know the Kubernetes, you could literally go spend 1,000 hours in there for free. And I don't know if you guys know what compute's worth, but 1,000 free hours is probably worth it with like a little trainer just hitting buttons and showing you how to do everything. Because that's all killer code is. It tells you what to do and you hit a button and it does it. Open tofu, yeah. Give me 1 second, guys. I gotta change something over here real quick. Oh, Colorman, I've been missing your stuff on YouTube. Oh, my bad. Hold on a second. Give me 1 second real quick. I gotta grab another water too. Hold on. I had to put this salsa my wife left with me in the fridge. Sorry guys, I've been missing everything on YouTube. Colorman said, gather data about Kubernetes pods and containers, APIs instead of web scraping. This is what GPT gives, logical. Back 2 hours, so you answer my bad. Yeah, Colorman, sorry, I didn't even see your things until right now. Let's keep going. Let's, all right, so what's the easiest way to fix this? We've done one. One's up. And one looks fine. No, one is hosed. Why is one hosed? His networking looked good. One looks right. Why wouldn't one come up? It's got lab internal. Let's watch him boot, because he should boot just fine. There's nothing giving him any heartache for number one. So he's one. He should be coming up as one. Oh, I know in a second here. So they're going and pulling. He's doing iPixie and he's booting up, and then he's going TFTP to pull down his Rocky 1 image. So he's the right node. Oh, you know what? If he crashes again, we got to rebuild all their overlays. Because the only overlay we built was 5. We'll overlay build the whole thing. If this crashes, we'll overlay build the whole thing. That'll hit all the nodes. It'll rebuild. I actually had a problem in this cluster before where if I didn't do an overlay build, some of the boxes wouldn't reboot. So that's definitely something for us to watch. Let's see. This is where it either breaks or works right here. For you guys wondering, we're watching a console of a virtual machine because there's no, you know, when we watch virtual machines, there's no physical way to connect to them, right? They exist in memory of the box they're on. So, nope, he stopped. Let's do an overlay build of everything. So that'll do 1, 2, 3, 4, 5. It'll hit all of the nodes, all the way up to 6. And then we're gonna reboot him one more time. And make sure that everything should be on there. We're using a virtual KVM. So it's similar. What's going on here, Node? Do you need me to kick you over all the way? There we go. Force reboot. That's like a power. It's like a power event at that point. Let's see these other nodes. Now, once we get into the node and we get control of them, then we don't have to do that anymore. Like I just go to Rocky 2 right here at any time, right? So I can SSH in. We only need to use the console when we're having problems with booting and functionality of systems, right? That's like System 101. If a system comes up clean and he's on the network like he should be, we can just jump right into him. And then the reason you might say, well, why do you like this more than this? Well, that might have showed you right there. I can't grab any of this data. I can't see this. I can't copy this. It's a terminal. It's a flat. It's like looking at a screen right here. This, I could grab all this and go throw it in my notes. And then I can look at it later and I can feed that into, shit, you feed that into Chat GPT and let it try to figure out. You can do whatever you want with it. But the point is, I'm not typing all this. I'm not doing that. Is it true virtual? It's virtualization in that it is system level. I mean, yeah. It's at the end of the day, it's all just jailed users. UForm, yeah, or your form. Yeah, that's all it is. It's just jailing processes, right? I'll show you. Okay. What are we doing here? So it's what would we call this? Yeah, it's QEMU under the hood. Or QMU or whatever the hell they call that. That's what this is under the hood. I don't go look at that down at that level very often. But yeah, that's how Zen's doing it. Okay, let's go look back over here. Let's see if one has come back up. One is back up. Okay. So, oh, okay, the time's right. Okay, I was like, wait a minute, he hasn't been up 39 minutes. He's been two minutes. Good. Okay, so let's go check Rocky 3. Man, I hate this. Is super annoying having to do this way, but let's go look at. Let's go check all of our nodes. So 3 is false, and that is not the right one for 3. So let's go fix 3 real quick, and we'll change him to Rocky 3, and his default is going to be set to this one. So we'll copy that, and then hopefully once this is done, we'll never have to do this again. And we'll make sure discoverable is false for 3, but we already knew that was the case. And then wwctl overlay build Rocky 3, and then you know, hopefully again that this never pops up like this again. But let's reboot Rocky 3, and now he should come up clean. Your form, yeah, I don't know. So I just know that XCP NG is on top of it. That's typically just the way that I interface with everything for this. I do other virtualization. I use like Versh for my virtualization on other nodes, but not in this. Oh, you know what I don't have? That's funny. I don't have any of my. I don't have anything behind me here. Hold on. You guys should be able to see. Yeah, you guys haven't been able to see me talking. That's been my bad. Typically, I leave that up, so that was my bad for leaving you guys hanging there, so you couldn't see what I was saying, right? I try to make sure you guys. If you ever wonder why am I only using 80% of my screen, it's because the bottom is for that. XCP NG is just a fork of the Zen hypervisor, so it's a type 1 hypervisor that sits on nodes, and then I can put as many different guests as I want on top of it. That's all it is. So the question was, what is XCP NG? And it's just a fork of Zen Server. Zen Server was bought by Oracle, and then people forked it from there. All right, let's make sure this node comes back up. If it does, then that's good. And I'm hoping that this never comes up again like this. But, I mean, look, if I got to manually set these, that's going to be a hassle. But I can get, I don't know, I think 10 nodes will probably be fine. Yeah, hypervisor is installed directly on the hardware, yes. Yep. You got to go right to the box. You put it directly on there. Yes, that's exactly how a Type 1 hypervisor works like that. Type 2 hypervisor sits on top of a machine. So like if you had Oracle VirtualBox, Virtual Desktop from VMware, any of those type of tools that just pop up, and then you can use them inside of an operating system that's already there. So it's like a second layer of virtualization. That's it. Yeah, don't. Oh, shoot. We have a failure again. Let's do a tail-20 on varlog werewolf. My guy is trying to grab from Rocky 4 again. So apparently I got to set all of them first. So let's just set all of them first real quick. So discoverable false for that. Let's go look at 4. It looks like Rocky 4 is bust. What is 3 set at? His networking is... Why is that wrong again? Okay. Motherfucker. What a hassle. Alright. Let's go set 4 to this bullshit. Right? Because maybe it didn't take the other one because... I don't know. And then we'll go set 3 to his correct one, which is that one. That's right. And then we'll go set 5. 5 should be set right, but we're going to set 5 anyways. Or we're going to check 5. 5 is set to 6.8, yes. And then 6, we're going to set 6 just for fun too. We're going to set 6. This is super hassle. This is not the way you should do this. Hold on. That is problematic. Why is his... he can be anything else. But he can't be that one. I don't know why his is the same. That's probably part of the problem. There we go. CE. Okay. So now let's go look at them all again. And Rocky 6 should also not be... Okay. Okay, there we go. Had not noticed before that there's background. Yeah, Monkey Man, I always have something in the background. I mean, I don't need music when I work. I think I've told you guys, I'm completely psychotic. I don't need anything. I don't need any music in the gym or anything. I could just sit there and do whatever I'm doing. But I put music on because I think it's fun in the background. I think it's good stuff. I haven't done dark in a while. Let's go dark here. Dark music. Alright, now we got to reboot. So 3 should come up now. Let's make sure. Hey, hold on. Overlay. Build everything. Let's just rebuild everything. We'll reboot him. Good. Alright, let's see. And Zendra, thanks for the follow. Hopefully this stuff's useful to you. I know it's been a while. I try to keep up with everything, but I also kind of get stuck in my own little world sometimes here. So let's go Rocky 1. He's up. I should be able to just do a... Well, I guess I can do it this way. Let's go. Rocky 1's up. Rocky 3 should be booting. He should think he's Rocky 3 finally. Right here. Nope, he thinks he's Rocky 4 again. God damn it. That doesn't make any sense. Alright, so I modify that, and then I look at it, not modifying it. Why is that not modifying that address? Do I need to do this to it? Is it just hardware address? Nope. I'm gonna have to figure out how to change that. So what I can do is I can actually export nodes out and reallocate them back in, but I didn't want to have to do that either. That's a lot of extra work for no real benefit. I don't understand how these got jacked up. Nothing changed here. I'm gonna boot this one just for fun. I want to see what this one boots to now. Does another one, like, does Rocky 5 grab this one and change its hardware address now? That's what I'm curious about. Like, does this go to Rocky 5 because that's the one that's set to discoverable? Yep, it did. And then it changed Rocky 5 to that one, which should not have happened. All right, but I've got another plan here. I've got another way to do this. Let's set all the nodes. So watch this. This will be fun. Let's set all the nodes. So we should be able to set all the nodes. Rocky 1. Oh, no. Square brackets. That should work. And then we can set all of them, whoops, to discoverable true. Right. 1 to 6. And then we'll do rebuild their overlays just for fun. And then what we'll do is we'll boot them one at a time, but we'll do that booting by recreating them. So let's go to, do I have a destroy in here? I think I have a, no, I don't have a, all right. So we're going to reboot each of these, and we're going to give them about 10 seconds in between them for fun. Do I have playbooks for my labs, or do I run configure VMs manually? Your phone, I do have a bunch of playbooks over here that will build my stuff, but when I first test and kind of get it working, I will sometimes build stuff kind of by hand when I'm first figuring it out, because I've never used this tool for this type of methodology before. No, Mystic Tour, all virtualization is a form of jailing, typically, or C grouping of processes, so that they just have their own slices of the system. I'll show you here in a minute. I got some talks on it. I'm gonna go slow through these. I'm giving them a little bit of time to come up before the next one goes. So they should grab all this stuff in order. This is not the way I'd want to do this. But I can use Ansible to reset these. So if this works, that would be a acceptable way for me to, I guess, roll through these with Ansible. I just gotta set that up. Hold on. This should be Rocky 1. This should be Rocky 2. Yep. This should be Rocky 3. Nope, he went to Rocky 4 again. This one should be... What the fuck is he? He's getting nothing. He's getting nothing. And he thinks he's Rocky 5. Fun. Fun, fun, fun. Alright. This is how I murder every node. It's how I just go off and just lose my mind. All of you, force shutdown. All of you, dead. That's it. Rodom, I finally lost it. You can tell people 5:54 p.m. on August 31st, 2024, I officially lost it. Alright, it's not that bad. Colorman said, Tanis, I'm new to DevOps and sysadmin stuff, and I can simply create playbooks and conf-YAMLs with AI and understand what it... Should I lean forward learning how to write these files or not? Colorman, I would say... if you can use AI to do a lot of that stuff, you should. I was even telling the people earlier when we were talking about this little sysadmin course we're doing. I think if you can, you should use the tools that are available to you to do the job. If you understand it enough that if the tool can get you 95% of the way there, you can finish it. I mean, that I see no problem with that. If, however, you just use the tool and you never learn how the thing works to fix the little intricacies, you will probably have a hard time maintaining hundreds and thousands of servers. Like I maintain all kinds of many clusters of thousands of servers, and the nuance is really kind of the value. And it's also the simplicity. I tell you guys all the time, I do very simple stuff, and you do that stuff well. So, yeah, Truva10, thanks for coming by. Yeah, your farm. Yeah, there's definitely, this thing is remembering these nodes in a way that I don't want it to. So I am going to delete all of these nodes. I'm deleting everything, but I'm not deleting the Rocky template. No, don't get rid of him. We'll leave the Rocky template because we're going to need him for this next part. And we are going to redeploy every node. But before we redeploy them all, we're going to come back here and we're going to set them all to discoverable true. Yep. We're going to go look at them. And we're going to say, here we go, guys. Are all of you discoverable? Okay, so node set's not working. I don't know why it's not working, but this is not working the way I expect it to. So no. I don't want to tag add, I want to change the tag. And I should just be able to set it. Oh, where is it? Dash dash discoverable. What? All right, now we set them all discoverable. So now, well, that's gonna bug me because now Y is fuck's the hardware. Screw it, I really don't care. We talked about last year, dropped out of med school, we'll go to university to study software. How can I improve myself until school opens? Truva, I would tell you, well, one, I wouldn't necessarily want you to drop out if you were doing, you know, something you loved, but I would tell you if you're waiting for something to do in between here and when school starts, I would go get my hands on systems. I would spend as much time getting my hands on systems. Killer Coda is a great one. There's plenty of free stuff up in AWS you can do, but Killer Code is probably the simplest and best way to start. And then I would just get in there and start building stuff, honestly. Building stuff, practicing stuff. Don't be like Ranger Dog, just laying around the whole time while you wait. All right, oh, hold on. Let's go. Let's rerun our playbook. Let's build this out. So this is going to build the nodes one at a time. As it builds them one at a time, they should come up here and they should grab the next part of this. So let's see if this works. Yeah, Truva, there's some really good. So for people that are algo guys, you want to go do like leak code, and that's stuff that is valuable for people that I know that are doing software type stuff. I would go spend time with Leet, Leetcode. Go watch guys like Midnight Simon. He might even be on right now. But there's really good people out there that are, you know, in the industry doing this stuff and are pretty good with algorithms and stuff like that. I think that that's where you want to go spend your time if that's what you want to do. I build the systems at the low level that people then. So hold on real quick. I want to watch this box boot. He should get Rocky 1. So he got Rocky 1. He's got a brand new naming scheme. Rocky 2 should get Rocky 2, and he should get a brand new scheme when he comes up. Hold on, Rocky 2. There we go. Okay, so it's deploying. So yeah, Python. I think all those things are great, Truva. I think there's really good tools out there. I think there's really good free stuff on YouTube and on Twitch for people that want to code like that. I would tell you, these are the things I would tell you while you're waiting though. Like if you're gonna go do formal stuff like that eventually, this is the other thing I would tell you to do. I would tell you go find some certs that are interesting to you, because then you're at least padding your resume a little bit, and maybe you're finding out stuff you like. Like you like algorithms, but you are probably going to, as an engineer, deal a lot with APIs. So I think you should go spend some time with APIs. This is like a 16-hour course right here on APIs. Probably somewhere between 12 and 16 hours of study, and then the tests are free, the tests are open book, and then you get cool little certs that you can put on your resume or whatever. I would go get, I mean, if you like algorithms, if you like engineering in general, all this Six Sigma stuff is just generic engineering stuff. You're going to deal with IPv6 in your whole career, so I would go learn a little bit about that. But my point is I would always be kind of doing stuff. Just memorize what was given to you. Software and algorithms were very satisfying. Well, there you go. There's a lot of stuff you can go do there for sure. But I would tell you my stream is geared more towards us kind of, we're building. Oh, why are these things turning off? I know these nodes were just up. What the hell? So they're booting. They're getting some basic config to them, and then they're turning off. That's weird. Alright, well. Failure disk not bootable. Well, that's a problem. What's wrong with this box? Storage. Rocky, he's on lab storage. Oh, no. No, hold on. No, sorry. I'm gonna have to blow all these away. My playbook is very busted. That's my bad. My storage, my disk, that's not right. Hold on. Rocky template. Storage. He has one on lab SSD. And this guy is over on lab storage. No, we need to be back. We need to be on this lab SSD. That's all fine. I'll just leave that like that for now. Alright, these boxes should all start. I don't know why they didn't start initially. Oops. But they did come up, and they did at least get their identity. So hopefully that's at least locked in. Yeah, Rocky 6. Okay, good. And then over here, we should now see those all with their new 1, 2, 3, 4, 5, and 6. Okay. Yeah, okay. That's better. That's more of what I wanted, because when I tear these nodes down and bring them back up, I want that to all work correctly. So actually, I'm pretty okay with that looking like that, because that's exactly how they're going to get deployed via even their hardware address is going to be the same. Yeah, this is good. This is the way I want it to work now. Let's see if this one will boot. It's slow, by the way, because now all the nodes are provisioning over the same network. And this hardware isn't, super powerful or nothing. So it's going to take a little while to build them all. But 2, 3... Yep, 3, 4, 5, 6. That's exactly what we want. Now, what we need to do is they're still going off of that slower storage, the lab storage. The reason we need to tear them down and bring them back up is because we want them off the SSD storage, which is the really fast storage. So there's that. Software is very competitive. Yeah, Mr. Couture, it depends what you want to do. I know, everybody seems to want to get into Fang and Mang and all that kind of stuff. And I think that in that sense, there's probably some pretty competitive stuff. I know a lot of organizations that I've worked with, they want people who are, out with a master's or a doctorate in like software algorithms and, have a track record of building all this stuff. But I think a lot of this stuff is still, good engineering principles, I still think kind of win out over just being some rock star coder, you know, that kind of stuff. So, yeah, but I think you guys should definitely, while you're waiting for school, if you're doing school, spend a lot of time figuring out what you kind of want to do. And there's too many free resources. There are way too many free resources for you guys not to just be able to go and say like, well, I you know, I don't think anybody should be. I tell my college students this all the time. If you make it a year into school and then find out you hate something, somebody failed you big time. Like, because I get students, I get 300 and 400 level college students. So this is, you know, in their last year. And they, you know, they effing hate, like, and I mean effing, as bad as you can think of effing, hate networking. And I'm like, you're a networking major. You're going to build networks. It sucks that you made it 3.5, 4 years before you figured that out. That really sucks. And I tell you guys that all the time. If you ever watch me do like subnetting here, or you watch me like, if you ever see me program a switch or something, if that bugs the shit out of you because it's so boring, that was the freest little advice you ever got, was not to go that route. Because seriously, some people hate it. Some people literally hate being at a command line. I tell you guys all the time, if you can't... Oh, jeez. Are we getting hit with a... Oh, wow, we are getting hit with a dust storm in Phoenix? Whoa. I just felt my whole house get hit, and I was like, what is going on here? And I looked outside, and it is like the brown of a dust storm, if you guys have ever seen... Wait a minute. This thing keeps breaking on... This thing can't load. I wonder if my system is overloaded right now, with trying to share these out and serve these out. Also, it seems like some of these are not coming up with. Looks like some of these are not coming up all the way. Looks like they're maybe rebooting themselves. Let's see if Rocky 6 came up all the way. Nope. So these nodes are in, and also they're on an old container, it looks like. That's not good. They should be on the Rocky Linux 9 lab, I would have thought. Oh, okay, the other ones are. That one I never changed over. Yeah, Mint, there's some really bad ones. My truck's inside the garage all the time, but yeah, I get your point. I get what you're saying. We are in some kind of strange boot loop here on these, so we gotta... Oh, they got their right IP addresses. So they should be coming up better. What am I missing here? Oh, Colorman, sorry if I'm missing new stuff over here. Yeah, I would always advise, if you're going to use a tool and you're trying to use the tool to learn something, that's awesome. Like if you want to use AI to help you learn how to code, I think that's a great use. If you want to lean on AI so that you never have to learn to code, you're replaceable, right? Like I would stay on the like use it to learn something and then go build new stuff with it. Do things that thing can't do. Because if it's just being a code monkey, man, that thing can code monkey better than any of us, right? But what it can't do as well as people is have ideas and design things, right? That's not, the systems are not to there yet. I suspect there's something wrong with the disks on these. I gotta watch one of these finish. I gotta watch one of these all the way to the end to see if it reboots, because like the disk isn't working. I think that's what's happening. That's causing these to crash. I think that's what we're seeing here. Oh, by the way, over here I can do a tail-f on var log werewolf and see what's going on. Is the network jammed up? What's going on here? This system in general should be fine. Let's see what his networking looks like. His performance should probably be fine. That's not very high usage across his CPU and his memory and his network. That's relatively low. Remember, it's not actually using his network, guys. It's actually using his memory because everything's happening internally. His CPUs are sitting at about 15 to maybe 20%. That's almost nothing against 32 CPUs. Yeah, so these should be booting just fine. They should be. Why they're coming up so slow? Not 100% sure. I'm not used to seeing this move this kind of slow. I can go back and look at the memory performance and CPU performance. It's a little higher, but that's not that high. Yeah. Yeah, ops to dev. There's too many people out there showing you how to do it, like practically. Like the one tomorrow that Salty's doing. Salty is coming down. You know, he hops on here every Sunday and shows you guys how to code. His stuff is excellent. If you guys haven't been following his code stuff, he's been building little bots out that work inside of our Discord. He's been showing people how to do GitOps and all that kind of stuff. He's been showing people how to be part of a software team. So he's huge on that. And then also, yeah, we've got the Linux System Administration course that's coming up where we're just going to start at the beginning and go through everything, right? So, yep, all that stuff. All right, that's all free. Anybody can come and do that. I really look like I've locked up this node. Like, I wonder what the performance of this guy looks like. He's not doing nothing either. This whole system's just chilling. This kind of bugging me a little bit because, like, this system should not be taxed like this. Where's the disk at? Let's go to performance and look at the disk performance. Is the disk topped out? You know, we got multiple different disks here. But this would be interesting because these are going to the, right, all these boxes are storage of the lab storage, which is a slower set of disks. You know what? Hold on. Let's go performance. Come on. What's going on here? Why are we going so slow here? He should have disk performance here, but I don't know why he's not. I want to see his lab storage. Right throughput. Yeah, it looks like that's spiking. All right, we're killing all of these. We're gonna try something else. We got the basic thing that we want. We've got the pieces that we want. That's all good. Let's kill them real quick and let's start them up again. We're gonna delete them all and we're going to put them all, but we're gonna put them on the right SSD now. And we'll give them 20 gigs is fine. That's fine. We're ready to deploy them as soon as they're down, and as soon as we've deleted them all. We'll delete all those guys. Good. Okay, there we go. Yeah, I would always advise, like what's being said down in the Twitch side, is go spend time with definitely go spend time with Killer Code. It's like the best free thing on the web. Best free thing around for you to learn this stuff. I need to check. Hold on. I need to check my other email real quick. Hold on. Did anybody ever put... Nope. They never sent more stuff. I thought we had more stuff we were going to do today for work, but nope. Nobody ever got around to messaging me. Okay, so this is a pretty cleaned up environment. I'm going to go deploy my werewolf again. Ask vault pass. hit up my thing. This is going to deploy, and over here, now my prediction for this is going to be much faster now, because these are on SSD disks for the back end. So these should be, theoretically, so much faster. Like, we're talking, it's a RAID 6, it's SSD, so we're talking, you know, one order of magnitude faster. So 10 times plus faster than the other systems. So let's see. Let's go to his storage. He's on lab SSD. Yep. And his console should come up, and he should be able to be, he should be node, yep, he should be Rocky 1. He should grab this disk very quickly, I hope. What's the business app for these modes? Nothing, Couture. I'm just building them for fun. Just being a Linux engineer and building stuff. But wait, back up a second. I will be using these for the professional Linux users group, like for people that want to do the labs and stuff. They will have access to this. So that looks faster, but that could just be in my head. I hope this comes up and starts. That's what we expect. Boot, start, get to a running config right here. And again, should be faster because the SSDs on the back end are much faster. Okay. We did just... We're not doing overlay build of everything again. We're going to do that anyways. Oh gosh, what state is that? I don't even know what state that just was. Let's start these guys back up and give them another shot at life. Now these, the overlay's been rebuilt, so this one should hopefully... Failure, disk not boot, that's fine. I don't care if the disk is bootable. He's Rocky 5 like he should be, okay. Huh. Yeah, no, Mr. Couture. No, all I want with these nodes is for people to be able to get in and break stuff and build them. That's it. It's just simple little build nodes. Simple little things for people to mess around with. And when I say mess around, I mean like come in and do the labs. I've got labs that are written up for while you guys are. So like I've got a ProLUG, LVM, and RAID, which just has you go through and just do a bunch of work around raiding out the disks and turning them into logical volume management disks and then clear them out and all that. Oh yeah, no, Mr. Couture, this is just to give lab access to everybody to have one individual little... Did that just reboot again? No. Hold on. I need to watch one of these all the way to completion. All the way up. There's something with this that I know I've set before, but I don't remember. Ipixia's Dracket. Root is not init RAM FS. Root should be hold on. Let's go look at what are the other root types. There are different root types for this. Let's go look for boot management. Init RAM-fs. That's not the one we want. That's the one that we had originally set, but we need to be maybe we did set that. Track cut for the iPixie. Yep. iPixie track cut. And then it's got the right package in it because I built that package in on the Rocky 9 lab, so that's right. What else did I change on here? Which node serves the front end? Mr. Couture, it depends. In this case, the node that people will come in on to jump into these nodes will be my jump box, which is P01 jump 01. People will jump through this node and then go jump into all the different nodes from there. So there's that, but that's, I don't know if that's what you're asking. Hold on, I gotta find, what is this that, I have that booting right, so why are these back to this again, where they refuse to boot? They're doing drag cut Rocky 1, that's what I expect. They've got a big enough disk on the template provisioner. The disk should work fine. Huh. Yeah, I'm not sure what's going on. So I got all my nodes right, but they're not booting for some other reason. And that reason has something to do with init RAM-fs is fine. Drag cut with the iPixie is fine. I never set that for Rocky 6 though. Let me go check Rocky 6. Yeah, he doesn't have that. But see, his root is init RAM-fs, which I'm pretty sure. Hold on. I'm pretty sure it's temp-fs I'm supposed to be booting off of. No, hold on. Fuck is this temp-fs set? That doesn't help. I know we can set that. Can specify temp-fs. Let's see. We need to set that, but hold on. Let's do help again, because we need to figure out how to set that root. Okay. Let's set Rocky 1. 1, 2, 6. Root is temp fs now. Okay. On all of them. So we don't care about that anymore, and we don't care about that anymore, but we do care about temp fs. Is that set for root on all of them? Yes. That's, I mean, that was different before. So let's go to all of these and force reboot. So, because they shouldn't be using init ram fs, they should be using temp fs. So let's see. What's going on, Ops Dev? You're asking if one Scott is doing, he's building these nodes for people to use. Yeah. Yeah, these nodes are just ephemeral nodes in my system that could be used for anything. What I'm going to be using them for is for people to log in and do stuff on, yes. Although they're going to definitely get blown away at least one more time, because, here's why. Oh, I might have to rebuild the overlays. Hold on. One more overlay build. Just overlay build everything. Screw it. Does it say temp fs? Still booting via Dracket. That's fine. But now it should come up correctly. We'll see. Yeah, Ops Dev, that's the point, is giving people access to build these things. So you don't have to build everything yourself. That's exactly right. Excuse me. Also, it's the last day of the month, so I figure I'll be on here for a little bit. Kind of hang out a little bit, get my hours up. I hadn't been streaming as much the last few weeks. I've been really, really busy. I have more doctorate stuff to work on. I have more other stuff. Well, Mr. Couture, there's a lot of stuff going on here. I mean, we're troubleshooting stuff. We're trying to figure out what's going on. Once I get this, and it's almost like you're watching me figure out how to build a recipe here. I haven't done this before in this type of system. So I'm trying to figure out the behavior of the cluster, and there's a lot of things right now that I'm very confused about, because I don't know why they're doing the things they are. But as I learn those things, and then as I pick them up, this will be a cluster that I'll be very proficient on. I have a bunch of clusters that I'm really good at that I've been running for a long time. XCat, now Bright's one that I'm pretty good at, and like I can build things and do all these things inside of those nodes, and so this is something that, like, I guess most people wouldn't see, except that I'm building them out for the lab. Normally I just do this while I was watching like a show or something on TV. Why are these nodes not coming back up? Hold on. Start. But, well, I won't say that. Let's just watch these nodes boot. Let's just watch them boot. That's what we're doing. Trying to figure out why the nodes aren't behaving the way we want them to. This one's on the wrong container, so I'm going to have to fix his container. That's fine. These other nodes should be starting and should be coming up. I literally don't know what you're saying, Mr. Couture. Why would anybody need a cluster? So, supercomputing? Thousands of nodes? Like, you can only fit so much in one physical server, so then you expand out to multiple other servers? Like, I mean, like, that's why. Also, it's starting to rain, which is and thunder, which is much more, less. Hold on a second. So this was a cluster I built out. I'm hoping you're genuinely confused and you're not fucking with me. I really am hoping that. But so like you want to process all you want to you want to process all the data in the world for weather, right? And this is the rack. This is the cluster. These are approved pictures. This one is in Manassas, Virginia. This is not the one in Phoenix. The one in Phoenix is just by my house over here. So, oh man, and then that's heavy duty electrical coming down, and then water. These are all liquid cooled, but this can process literally everything that from 2 million plus sensors coming in every 6 hours for all the weather, pretty much of all the world, right here. There's more to this rack, but there's another set of racks for this, but this is what's approved in the picture, what can be shown or whatever. This is all. So any one node can't do it. So now we got to expand to multiple nodes, if that makes sense. Mr. Couture, I have to assume you're drinking. But anyways, let's see. Hold on. I got to figure out why my nodes aren't. Man, these things are taking their damn time. It's probably because Werewolf is still. I still got Werewolf over on the other disk, so his disk can probably slow us all down. But yeah, I mean, he's not even hardly doing anything. Anyways, yeah. But yeah, in my case, I'm just building a cluster to build a cluster so that people have lab environments and they can do whatever they want. So, there's a question on YouTube: can I give Terraform usage versus Ansible your way? Yeah, well, I mean, I haven't. So, I went and got a Terraform cert in 2020. 2021. Kind of to. I did that to get ready for using Terraform all the time at AAA. And then the day I got the cert, the next day I went into a meeting and I was like, all right, we're ready to do this. And they were like, oh, we're going to take a different direction. We're not going to do Terraform anymore. So anyways, what I would use Terraform if I was trying to stand something up for the first time in a like cloud environment. I would use Terraform for that. But for every other thing, I would use Ansible. So I will run Ansible for pretty much everything if I can. So yeah. Again, this is super slow right now, and I'm surprised that it's going this slow over the SS because it's going to the SSD disks. So I would expect these to be. I mean, we got the systems booting. They're all going to the right names. All the stuff is right on them, but they're still just, man, they're just going so slow. And this box should not be that under load that it couldn't handle this. Like, this box should be able to handle this no problem. Memory's fine. Disk is fine. Like, this should be almost nothing right here. So, all right. What else do we have here then? While this is doing whatever the hell it's doing, let's go watch this go. I wonder if I have. So I might have to go check my TFTP configuration. Maybe I have some kind of limit where it's only going to do so much. Oh. Yeah, I mean, yeah. Most of the time when I build stuff like this, it's physical nodes. It's not virtual machines like what I'm doing here. Out in the wild, I do this stuff over. High-speed InfiniBand links. But let's see. All right. Yeah, nothing going on there. All right, so there's many other things to do high-speed computing, high performance type stuff with. There's satellites. There's or any kind of orbital systems, but satellites are the ones that I used to use them with. Um, there are chemical applications. There are biological applications. There are business applications. There was a bunch of that over at the college that I was at. I've worked at a few colleges for high performance compute type stuff. So yeah, like everybody needs their own cluster. And the one college I was at, their cluster wasn't. I mean, if I had to guess, it didn't cost. It didn't take. If I had to guess, it didn't take 100 million to build it, and they were making $1 billion a year in research money. So that's pretty good for a middle, like mid-sized to but kind of well-known college in the middle of the country. Yeah, so there's a lot of application for big supercomputers. We're building a very small version of that that's obviously going very slow. But you know, we simulate these things, and then we learn some of the techniques around them and figure out some of the behaviors of how these things boot. And then we take that over to when we actually work on the systems, and then that makes us able to troubleshoot them and understand the behaviors better. So that's what we do. At the end of the day, it's still just a simple node. It's one simple node doing a simple node thing. In fact, I was telling you guys yesterday, I got done. I was stigging a server. So stigging are the security things. Over InfiniBand, I can have right now. I'll do like quad, not HDR. I think it's SDR, and they're like 200 gigabytes per second. Sorry, 200 gigabits per second over that. But then I can have 8 of those links into a machine, and then each of those links can go directly to like a GPU, and there's some real speed going out of there. I mean, you can get almost you can move almost a terabyte a second of data between them and the backend storage. A bunch of letters. You can ask me any question you want. Yeah, you can ask me anything you want. Yeah, Mint, it depends what we're dealing with. In fact, I think I was telling you guys, my company, we've been working a lot of subs under Dell, like Dell contracting stuff, and we're going to be working on one of the clusters coming up here soon that's going to be, it's going to be number 1 or 2 in the world when it debuts for the top 500. It'll be the fastest in the world for years. It's a brand new architecture between Dell and NVIDIA that we're going to be working on. So, yep. This thing is ground to a halt, man. We might take all this and say, we might calm all this down. Also, this music needs to calm down. Hold on. Next one. There we go. Next musics. Yeah, this is going about as slow as I can imagine anything ever going. Alright, so we're gonna force shut down. Force shut down. Yep. We're gonna do just one node. We'll just do Rocky 1. Force reboot. We've redone the overlays over here. Everything should be up. Alright, let's watch them boot. Yeah, Robdom, this is my darker track set. I have all kinds of. I actually have a pretty good one that I haven't played in a while. Hold on. This one's fun. Hold on. Acoustic. This one should boot pretty quick because now it's the only one. He's coming up as Rocky 1. Good. I don't know why all those other ones were stuck behind whatever they were stuck behind, but let's get this to go. They're pointed to RAMFS or still booting in at RAMFS. That's not what I expected. Here I expect it to boot as RAM. Okay. We did our overlays. We've seen this before. I don't remember what we did though. That's current. We definitely ran into this before. FS, some overlay. Those are definitely all the same things they were. No, I don't need to do that. Yeah, quartz one. I put that salsa in the fridge, but that stuff was pretty good. Man, I remember us running into this before. And then I remember... I thought we fixed it by making sure that we had root going to tempfs and drag cut, and then we put that into the image. Now that's still built into the image. That image hasn't changed, so that's there still, meaning that these should boot. We didn't change anything else about these. What else? We set that. That was the other thing it could have been. Init RAM FS. Yeah, I don't know. We're gonna figure it out. I might just kind of be spinning my wheels at some point, but a lot of times you just go about it and then you eventually get it to work. Let's get this out of the way. Probably don't need that right now. Give this Rocky a start up again. It was set at init RAM FS before. We're going to give it another shot with init RAM FS. But then that wouldn't make sense to me why. Let's see. To watch it boot. What's the worst thing that can happen, right? Is that it just boots up and comes up the way we want it to, and be a drag hit. That's what we expect. It's doing init ramfs this time, so that's fine. That's what we have it now set to. Still fatal. These were, hold on, 15 gigs, and then over here they're 20 gigs, but they're on a different SSD. XVDA, nothing's changed there. DPKG, what did you ask? I said you could ask a question, but I didn't see what you said. Oh, so I'm a software developer working on a laptop with 16 gigs of RAM. Sometimes I need to run multiple projects together with multiple Docker Compose, which consumes quite a lot of memory. Laptop becomes slow. Right now I rented a VPS and do development there by connecting the VS Code via SSH. Any better solution for my problem besides upgrading my laptop? Well, yeah, I mean, I guess it would depend. I mean, if you have multiple things running and things have to stay active, you know, you can't disable certain things and that kind of stuff. I would tell you probably, for me, the first thing is definitely, if I can, and some of you guys have seen this, I try not to do anything on my actual laptop. My laptop right here, I don't want to say it's sacred. I do some things on it, but it's like everything I do, I offload if I can. So, in that sense, I try to do everything like completely, you know, up in my cluster environment. So all this stuff I could just beat this stuff up and shut it off and do whatever, and I don't affect this machine. I could be doing this streaming and like watching Netflix or something, and it wouldn't affect the system because all of this stuff is off of my, like, I keep my laptop kind of sacred, which is just because I've done so much stuff where I slow it down, and I used to dual boot stuff when I was younger, and I just don't even care to do that anymore. If you have to use your desktop or your laptop, I would tell you probably you have to upgrade it. That would be my thoughts, you know. Because my laptop here, it's a little Dell G15, but it's got 64 gigs of RAM, and it can charge through things pretty well. But yeah, I keep things things separate. Depackage, yeah, that's what I do. I'm just gonna call you, it looks like depackage to me. Sorry. That's what I would do. I would definitely keep things separate. I wonder if this thing can't work because it's a different size disk. But that doesn't make any sense. Let's go look at this. Let's go look. What's going on in here? I want this thing to just rebuild these things all from scratch. We don't need any of those lab disk ones. All right. So those are brand new. Was root just RAMFS before? Do Control R and then I think it was just RAMFS maybe. Build. Let's go look at I don't know which one of those looks right, but we'll figure it out. Alright, so that's what we're doing, guys. We're just hanging out. We're working on stuff. Robodom, what were you saying? Here I am worried about being able to watch streams while working on coding projects on my main PC. Yeah. I made the switch a while back. I had never run like laptops. I had always just run desktops, and probably a little while ago I got back to just I now just do laptops for things, you know, laptops for everything, and it works pretty well. I have my main monitor here, and then I have a couple of other monitors. I got a big monitor over here that I do all my work on, and it's actually funny, it is about that big. Maybe not quite that big, but it's a pretty big monitor, and yeah, it does pretty much everything I need. So MFS. Curious why. It's right where it's going to fail, if it's going to fail. Right here. Yep. Still Dracut fatal. I definitely fixed this same problem before. I just don't remember how I did it. I probably have notes on it, because I do like to keep notes on things, right? All right, so where are we at here? We are building out the lab stuff. I think I'm closer, but I did break some stuff tonight, so I'll have to go work on that a little bit. Let's go look at, what's another thing we could do here? We don't need to go over security stuff. You guys don't want to go over security stuff tonight, do you? Let me show you guys this. You know, we got a Discord. We've got a bunch of free activities out there for you guys. If you want to go look at those, plenty of people be involved in those. Plenty of free certs you can go work on. Plenty of just stuff to go hang out and, you know, talk shop with people and all that kind of stuff. What I'm probably going to do, because it's storming outside pretty good, I'll probably drop off of here, but be ready for labs tomorrow. If you hop on, we're just going to start at the beginning and do, you know, basic Linux from start to finish. And we'll ask ourselves some questions. We'll do some of the Socratic method as we go. We'll do the labs, and then we'll ask ourselves different questions as we go, and just get as much stuff as much in our heads as we can. So, all right, let's go find somebody to raid. I'll put myself on my little end of stream thing here, and hopefully we find somebody doing something fun out in the world. Oh, BlazeBits is on. He's doing stuff. Midnight Simon's on. Some of you guys were talking about that. No, let's go hit up we'll go hit up BlazeBits. He's doing good stuff. He also does what most of you guys consider hacking, right? Going in and getting into systems and stuff. He's a professional pen tester, so we'll go hit him up. I appreciate you guys all coming, and I will see most of you that want to hang out tomorrow.